also seen some project related to the churn prediction, right? Project related to the churn prediction by using the logistic regression. So let's go and understand the logistic regression. Then we're going to decide details about the our project. So logistic regression is a classification technique, but since in the name itself it's called as a regression, but it is a classification technique where we have to do some of the classification tasks by using the nonlinear transformation. So you can see in this image, you will get nonlinear transformation for the logistic regression. We can also call it as a logistic curve for this matter. And for the linear, we also another model called the linear regression. We're going to be get maybe the upcoming classes as a linear model. We're going to be showcased as per the regression techniques. So it completes a linear model when we are going to separate any kind of the two class classifications, or but it is a regression mechanism, not a classification mechanism as a linear model. But the logistic curve or logistic model is going to be help us to understand to separate any class classification, whether it is a binary class classification or the multi-class classification. Let's go ahead and understand what are the different mathematical functions and what are how does logistic regression going to be help us whenever you have it binary class classification in your data set. So I am on the page of Medium blog. So where here going to be explained some of the mathematical terms. I also taken some of the images what I have written by using the mathematical formulas. So let's go in some of the geometric intuition and also going for some of the loss interpretation of this model. So we can tackle out logistic regression with the three interpretation. One is a geometrical, and when another one is a probability interpretation, and another one is loss minimization. I can say we're going with geometric interpretation first, then we have to go with maybe the loss interpretation. Somehow that going to be help us by using this diagram. So let's focus on the geometric intuition. How does that going to be help us, and what are the different terminologies we are going to be used this? So let me take you this in a snippet. So you have two classes here. Okay, so one is the positive classes on the side of hyperplane, and another one is the negative class classification. We can represent it by using the positive, and then for the another class we can represent by using the negative. So how do you separate by using these two classes in your hand? So you can separate by using the plane, you can separate by using line like this, or separate by using the line like this. What if you have a point on this side as a negative point, and what if you have a point on the right side or the positive point in the negative end? So in this case, how do you tackle out by using the logistic regression? Let's go and check out this example. So here you can see we just drawn some plane here. It's corresponding to separating two data points or two different classes what we had. Let's take this as example for the positive and this example for the negative. So we separated by using the plane called P, or we can also called as a pi for that matter. Let's use our terminology is called pi. So I have a plane with pi, and I would also call something called as a norm perpendicular to this plane. We can also call it as a norm. I hope you know about the norm. So we can represent it by using W transpose. I have a W pi p, and with corresponding to the norm, I will write it as a which is perpendicular to our plane, which is also called as a W transpose. So okay, everything is set up. Whenever you have positive points and also the negative points, we draw a plane. According to that, we also draw the normal. And how do you calculate somehow to whenever some of the points come across with the negative side and also come across with the positive side, how do you calculate, and what are the interpretation between the geometric for the logistic regression? So if I have a let's take this is the xq value. This is unseen data point in your training data set, and corresponding to the negative side also we have an unseen data point. So what exactly the logistic regression will do here? It will take a distance from this point to hyperplane. Okay, it will take a distance from a point, that unseen point or unseen data point to the hyperplane, and it will calculate the distance. Let's take the distance we'll get. Okay, so the distance you will get, then what it will do, it will take and transports corresponding to your yi. These are the yi's, obviously. So yi is having around you have a data set with positive and also the negative results. So here we are not considering as a zeros and one for any kind of the label results. In the probabilistic interpretation, we can conclude as a zeros and one, but geometric interpretation, we can conclude it as a positive and the negative results. So this is a very interesting ideas whenever we do geometric interpretation. So I hope you know about something called as a distance. You can say distance of a point from a hyperplane. We're going to be get as a W transpose X by norm of the W, the distance from a point to a hyperplane. So this is the distance we are going to be get whenever you calculate the distance between the query point to the hyperplane. So let's go and discuss on this blog. He explained very brilliant with respect to some of the equations like this. So distance between a point to the hyperplane is W transpose Xi, and by the norm of the W. We're just calculating the total norm of the W, right? So what will happen if you take a distance between a point according to the plane, it is almost perpendicular, like we just now discussed with corresponding to the norm of the W. So it is also perpendicular. At the time of its perpendicular, norm of the W is going to be equal to 0, right? Which is going to be equal to 0. Or you can also, sorry, it is going to be equals to 1, the weighted vector of the norm W. So in this case, the norm W is going to be always 1 because of the perpendicular. So you will eventually get the distance W transpose Xi. This is the left, you're going to be left out with that. So whenever you got W transpose Xi in the positive side, that is greater than 0, the classes becomes as a positive. Whenever you get the W transpose Xi is less than 0, the class is going to be negative. So like that, you made some of the assumption by using this distance calculations. The distance is greater than 0, you will make as a positive. The distance is less than 0, you will make it as a negative. So like that, you make some of the assumption with regarding the logistic regression. How come that going to be helpful, and what are the different statistics we are going to be handled together? So these are the 4 cases we are going to be handled together. One is, if suppose you have a xq value is positive. So let's take this diagram again. So you have a xq is positive and ya is negative. At the time, what will happen? I hope you already know about some of the probabilistic interpretation between the positive and the negatives. So you have a yi with corresponding positive result, and while computing your W transpose Xi is positive. So what will happen if you just directly multiply this together, yi into W transpose Xi, you will get the positive result at the positive query according to that. This is the first case study. And what will happen if you tried with yi negative along with the W transpose Xi? That is that you're just predicting as the actual class values as a negative value, but you are predicting as a negative. At this time, you will get the positive result. That means W transpose Xi is going to be greater than 0 because of the negative going to be multiplied together. So similarly, you can see we are just taking the yi is a positive and W transpose Xi is a positive. You will get, if you just multiplied, you will get the results is greater than that. That means you're going to be get as a correctly positive points. And whenever you take yi is positive and W transpose is going to be negative side, that means in this case, this is the class variable we are just considering without any interpretation. And you will go eventually going to get, whenever you multiply with positive and negative, you will going to be get as a negative results. That is incorrectly classified points. And you are predicting value, or you're assuming as a yi is negative and your actual class label is a positive. So at this time, obviously negative into positive, obviously negative results. This is also not incorrectly classified point. So whenever you take as a negative results as a yi, this is the assumption you make, and this is the actual class label we have, the negative result. Obviously negative into negative is a positive. That means you will correctly classify the points whenever you have a negative result, and also the whenever you have a positive and a positive results. So that means you can see somehow we are having some assumption to get rid from yi positive and also the yi negative. So in this case, you can see incorrectly classified points is not eventually calculating the corresponding predictor values, but eventually calculating only the corresponding predictor values is yi w transpose xi is greater than 0. You can see the w transpose and xi is greater than 0 for this case and for this case. That means we are just maximizing the distance. So we are corresponding to maximizing somehow distance between the actual class labels and the predicted class labels. So for that, we can write some of formula like this: argmax of totally yi into w transpose xi. We need to maximize this all the data points, whatever the data points corresponding to our independent labels in our data set. So for that, we just write argmax of w and maximizing this lambda. So here we are going to be get yi's in our data set, xi in our data set, but w transpose is only the scalar part. This is ideally going to be changed every time, right? So these are constant, these are the constant. So eventually maximizing this corresponding wi, that is the norm of the w, we just now shown, right? And maximizing this lambda. So here we are going to be get yi's in our data set, xi in our data set, but w transpose is only the scalar part. This is ideally going to be changed every time, right? So these are constant, these are the constant. So eventually maximizing this corresponding wi, that is the norm of the w, we just now shown, right? Norm of the w, we're going to be corresponding to that. Every time it's going to be changed at the time of this algorithm is going to be run together. And what will happen somehow, you will going to be get, yeah, so let's take maybe, yeah, this diagram. So what will happen somehow, eventually all the data points may not be in the right scale, or you can say right matrix at a time. You will have a data points according to x is equal to 200 and x2, you can say x1 is equal to 200 and x2 is equal to 100 and x3 is equal to very large number like 10,000. Okay, so in this case, how do you handle it with responding to x3 value? This is somehow we can also call it as an outlier for that matter. This is very far away to whatever the actual values we have. These are some of the actual values with the same scale, and this is some of the different scale. So how do you arrive at that time? What will happen if you just calculating by using our distance formula? It is very far away to our distance. At this time, it may not be identified as a positive label or the negative label, but we cannot be considered this is going to be positive label or negative label. If you consider the positive label by using our calculations, so just calculating our distance by using this. So suppose this example, you're just calculating the distance of the 20 from this point to our hyperplane. If suppose I calculate all the points corresponding to all the points, and if I just subtracted by the negative point results what we had, eventually you're going to be get as a very large number. Okay, very large number when compared to our we just predicted as normal predictions, or whenever we had large scale of the numbers we had at the same scale. In this case, we are getting as very too large number. So that is the reason we have to squeeze it in, or we have to squeeze it to somehow to smooth our curve. So we have already seen how does that going to be help us as a logistic regression. It's lies between 0, 1, obviously. The first image we've seen, right? It lies between the 0, 1. Whenever we squash something or whenever we smooth something, it's going to be give as good results. That means we are going to be enter as a 0.5 results it somehow. So for that, we have another function called as a sigmoid. So the sigmoid is basically looks like as a logistic curve like this. Whenever we had logistic curve, we're going to be get as a hyperplane to get maximizing the distance. Whenever you get some of the outlet like this. So for that reason, we just make some assumption to smooth our curve or squashing our curve to get this sigmoid function. The function definition as follows: 1 by 1 plus e to the power of minus x. So in this case, we just applied whatever the x we have, like y into w transpose xi. If you just substitute in our formula, you have this one, right? You have r max of w ya transpose w ya into w transpose xi. So just substitute in our x formula 1 by 1 plus e to the power of minus ya w transpose xi to just apply our sigmoid function according to that. Then you will get this formula, argmax of the W, maximizing our W and according to all the data points what we had. Then what will happen if you just keep on applying it? We just call it as a logistic function, but does not mean we just normally call it as some function. The sigmoid function also we can call it as for this model. But why we need call it as a log functions? And that is also one matter. And something called as a monadic functions. You already know, right? Something called as a monadic functions is going to be, if suppose you have a function like f of x, it's going to be increasing. G of f of x is also going to be increasing. We can call it as these functions monotonic functions. And if you have a f of x, it's suppose going to be increasing or decreasing for that matter. If suppose I applied the log of f of x, it's also going to be increasing and decreasing. Whenever the f of x is going to be increasing, it's going to be increasing. Whenever f of x is going to be decreasing, it's also going to be decreasing. So similar fashion, we just apply together to reduce our minimization of the function. So currently we are using the maximization of the function. To reduce somehow the minimization of the function, we can use the log function. So you already know, right? Log to get the differentiation of the log of differentiation of x, d by dx of log. So 1 by x, we already know about this formula. And I hope you already know about the 11th and 12th grade. So to minimize this argument of this function, you just keep applying for a monatomic function. It's always going to be helpful whenever you have logistic regression to apply. So just apply this formula together whenever you have 1 by 1 plus e to the power of minus x. All the time it will be computed by using the 1 by x. The 1 is going to be removed and it will come on the top. That is the reason we are getting 1 plus e to the power of y minus w transpose xi. So what will happen if you have this function, log function, along with somehow constant results, you can say. So this is the minimization, we can also call it as a cost function for that logistic regression. Then you have to reduce further, or then you can also upload, you can also minimize further by using some regularization term. So you already told about something called as an outlier. So this is our outcome. We are going to be compute some of distance like 20 or 50 or 100 maybe. What will happen if you have a value around plus infinity and also the minus infinity? So you don't know that much of clarity to get the distance. Some of the points may not be concluded with somehow distance. So at this point, you can use something called as a regularization terms. So the regularization terms is going to be help us to fine tune or to just adding some of the penalty to it. Okay, adding some of the cost function penalty to it to reduce some of the distance according to the sum of the points having the positive and also the negative distances corresponding to the two different classes what we had. So the lambda is a hyperparameter tuning here and hyperparameter for the logistic curve, and the W transpose into W, we can also call it as a L2 norm for the logistic term or the regulation term we are going to. And this is also very helpful to do something called as overfitting of our problem. So we're going to be discuss maybe in the next classes how does overfitting and underfitting going to be help us and how to avoid and what are the different techniques we have to tackle together. But as of now, you can just assume like this is also going to be helpful to reduce somehow overfitting and underfitting of the results. Yeah, so L1 norm is corresponding to that will be the same. If you use both of them like L2 norm and also the L1 norm, we can also call it as elastic net for that matter. If you apply the law cost function plus regularization L1 plus L2. And the basic difference between the L1 norm and the L2 norm is L1 norm create the very sparsity. I mean, the more number of the zeros when corresponding to the L2 norm. So what will happen when you apply the L1 norm? You have a data set corresponding to you have some of the features. So if you apply the L1 norm, it will identify only the most important features. It will be identify only most important features, and the very less important feature it will be considered as a zero. That means you will get more number of the zeros in the end at the end. So that's the reason we are going to be get as a very sparsity vector or sparsity matrices if you directly apply the L1 regularization. And when you apply the L2 regularization, because it has something called as lambda square in the L2 norm. So it will identically going to be get that sparsity to increase somehow. It may not be create that much of sparsity. So that is a major reason. And this is how exactly the logistic regression is going to be predicted at the end. So obviously it's going to be do with regarding the majority vote whenever we have the majority vote with corresponding to the positive label and also the negative label by using the W transpose Xi. And some of the assumption obviously it's going to be linearly separable. If it is not a linear separator, you can add all the things like mathematical terms and everything. But this is a theoretical machine learning. You cannot be get it from in a scikit-learn. You directly use the function and call it for some of the parameters. You just directly calibrate the results. And you can also interpret by using the weight vector. That is also very helpful to fine tune that. And the space you cannot be get it from in a scikit-learn. You directly use the function and call it for some of the parameters. You just directly calibrate the results. And you can also interpret by using the weight vector. That is also very helpful to fine tune that. And the space and time complexity is obviously big O of n into d, because we are just recomputing all the results with corresponding to the all the data points. And the space complexity we are going to be get as a big O of d. We are just calculating only for the prediction results, right? That is basic assumption to make anything. So let's go and implement. And the loss interpretation, this is very interesting when compared to geometrical interpretation. So what will happen with respect to the loss interpretation? We already seen something called as a sigmoid function, right? So this is just a logistic function. So whenever you have a loss, okay, varying loss between the 0, 1, obviously, the varying loss, you have all the negative results. You can see you will get all the negative results whenever you have loss one. And whenever you have, it will directly decreasing drastically without any interpretation or smoothing curve. And whenever you have a loss equal to 0, you will get all the positive results. This is the positive side and this is the negative side, right? So whenever you get all the results and the loss is equal to 0, you will get the positive results. Whenever you have a loss is equal to 1, you will get all the negative results. But what will happen if you apply the log with the squashing? This is the squashing with the log. Squashing, or you can also call it as a sigmoid term. So when you apply the squashing, the sigmoid term with corresponding to the logistic curve, this is a logistic curve we had initially. That means the W transpose Xi. So whenever you apply that logistic curve, it will slightly decreasing. You can see slightly decreasing, not gradually decreasing, slightly decreasing whenever we have negative side of the results. And whenever you encounter the 0 term, here you can see whenever you encounter the 0 term, it's slightly decreasing again. It's not going down with corresponding to the loss value. It's slightly decreasing, and whenever we go somehow to reduce loss, so it's almost like greater than whatever we had, some logistic regression function. And something called as hinge loss also, when we are going to be used in the SPM model with respect to hinge loss, we're going to be calculate some of the loss with corresponding to the kernel. We can also get it from the SVM. We have two types of the SVM, soft SVM and also the hard margin SVM, and some other squared loss also. Okay, so these are losses. By using the losses, we are going to be get so many models. So by using the logistic loss, log loss, we are going to be get logistic regression. By using the hinge loss, we are going to be get SVM. By using the square loss, we are going to be get another model. So like that, we are going to be get all the models only for the loss interpretation. So this is also very interesting, I can say. Whenever you read, this is going to be very helpful to minimize our loss somehow. So let's go and implement the logistic regression. This is not our project. This is some sample notes to understand the logistic regression. How does that going to be helpful? You can also read some of the interview questions. How does that going to be helpful, and what are the different assumptions we have? Yeah, so these are the standard libraries which are going to be showcased in the logistic regression model. So this is a sample data set. I think this is the data set with regarding some passengers details and also whether a person is survived or not with corresponding details. Okay, so I think this is a Titanic data set maybe. Yeah, so we have some of the classes according to the travel details and also the fare and the age and the survived is the target here. So this is the target variable. These are all the independent variables. So let's also make some assumption to separate our dependent and the independent variables. So I'm just dropping the dependent variable survived one in the X data frame, and I'm just keeping aside with the our target variable which survived in the Y data frame. The shape is very small, the data set is very small. You can also, and one more advantage for the logistic regression is whenever you have a large data set, it will work well better, because we are computing only for the distance of the data point side. If it is a tree based kind of the algorithm, it may not be satisfied with the large number of the data set. It completely fine tuned with respect to the time complexity. Because of the large number of the data set, it will compute the distance and calculate the results much faster when compared to the tree based mechanisms. Okay, so obviously we are going to be get it from the scikit-learn logistic regression or any other models. Okay, so currently we are doing as a train and test bed. So this is also one very interesting splitting mechanisms. So what will happen if you split randomly? What will happen if you split time-based split? So there are two mechanisms. One is a random splitting, and another one is a time-based splitting. So if you split randomly, you will get eventually all the data points corresponding to the train set and all the data points corresponding to the test set. It will split in the ratio of 80% maybe. It in the test set we are going to be taking consideration for the 20%. So what is the headache to learn for the trained data sets and the test data set? And one more thing, we can also get it from unseen data points, something called as a cross validation. So this is also very useful information to store somehow by using splitting of the concept. So you have a data set, but you have trained in your model. It will also identify some of the patterns, or it will identify some of the features to calculate the results at the end, whether you have to predict or whether you have to classify something. But how do you test it? How do you test it? That is the question, right? So if you have an unseen data points corresponding to whether a person is survived or not by using this example, maybe. So this is the training samples you have, but what will happen if I give unseen data points with you with your model? So how does that going to be helpful? In that case, we are going to be take train and test data sets. This is the test data set we are going to be get it from the train itself, and we can train by using, I can say, logistic model. We can train by using something called as a hyperparameter is lambda. We just now discussed with the regression term, right? So I will use train by using the model. I will use test data for the hyperparameter tuning or the other metrics, what are other parameters what we had. But cross validation result, it is unseen data point. We haven't seen this data point yet in our training models. So somehow people will call it as for the training result to do model plus hyperparameter tuning, and somehow people will do training with model only and test with the lambda. That means hyperparameter tuning only. They will also calculate in the cross validation data set. This is unseen data set. Okay, so you already productionize this model. You want to know about how does a real-time world is going to be helpful this model. So how does unseen data point is going to be help us this model? So by using the class validation test results, you can say class validation accuracy results or test results is going to be help us to understand whenever you done the productionization of these models. So at that time you will be get conclusion. You will also made some of the BRD to your end users, that is make good assumption to get rate from your problem. So that is the reason we are just taking consideration for the train and test split. So here we are just taking consideration for the 80 and 20 split, and the random set is nothing but we are just taking random data points. So yeah, so something called as the normalization and the standardization. So this is nothing but a rescaling of the data. I think we are going to be cover up this maybe in the next classes. The structure of this course itself is somehow you can say, firstly we have to cover up with all the Python skill set, then we can go into some of the EDA concepts, and then we're going to be some of the logistic regression and other models. But somehow the projects may not be matching with this curriculum. We have to change somehow. Okay, so let's focus on this notebook. We are doing something called as a normalization, right? So this is nothing but a rescaling of the data. Whenever you do you have all the features. Okay, so you have all the features with ranging different ranges. Let's take the future one having height 100 and 300 and 400, and future two also with the same as like that, maybe the 0.9, 0.7 or 0.6. So what will happen if you directly train to the logistic regression? As we already learned something called as a weight vector is equal to 1, right? So whenever you cannot be do any kind of the rescaling of the data which ranges from 0 to 1, or which are having the standard deviation is equal to, and mean is equal to 0 and the standard deviation is equal to 1. That's how the techniques will work, standardization and the normalization. But I'm just explaining intuition way how does that going to be helpful. If you cannot the rescaling of the data, it may not be give as a future interpretability. It may not be give as a future interpretability. That means we cannot be identify which feature having more interpretable when compared to that. And also it will going to be takes a lot of the time to run when compared to if you apply the direct feature transformation technique. So let's go and discuss this. So what will happen if you take these columns? So it will applicable only the numerical columns. Okay, it may not be applicable to the categorical, but we have only the numerical columns in our data set at last. So let's go this train data set. So we are applying to the train and also the test. What this rescaling of the data? You can see it is converted to the whatever the raw values we have. It converted to the 0, 1 in the range of the 0, 1, even in the age also. Yeah, let's also try to implement the logistic regression. Just now I told you, right, it will get it from the scikit-learn itself. In the linear model you will get directly import a logistic regression. You can also call maybe the alias for that matter as a log regression. So the KPI matrices we are currently using as F1 score. Let's assume this is some score you want to evaluate by using the logistic regression. I will also explain this with you maybe after a couple of the classes. F1 score something called as accuracy, and log loss is something called as a blue score. We are going to be using the Indian filtered context. Yeah, so just calling our logistic function by using some variable logistic and fitting our model. This is how we are going to be fitting our model W yi into W transpose into the xi. So we are just taking consideration for the train examples and also the labels of the train samples what we had. So if you fit this function, you will get all these parameters. Okay, so you can also directly showcase here itself in the whenever you initialization of the logistic regression. But what will happen if you eventually may not be go, we can call it as a baseline model for this one. And if you directly use these parameters by using any hyperparameter tuning techniques like grid search or random search, that will calculate the whatever the fitting of this corresponding data set. So if you don't know any parameters, what you need to do, go to the documentation. So eventually every industry is going to do the same thing. Okay, this is not a new time to do this. So scikit-learn logistic regression, you can mention as a doc. It will guarantee give this link. According to that, you go and learn what exactly the parameter does. What is a penalty? Penalty is nothing but a regression term. What is the L2? L2 we already learned, right? It's corresponding the value to reduce some of the minus infinity to positive points. And dual function. C is nothing but which is the inverse function of the lambda. Okay, so C is nothing but C is equal to 1 by lambda. C is equal to 1 by lambda. So you know, right, lambda, then the lambda is equal to 1 by C. So whatever the hyperparameter tuning you are doing with the corresponding to the lambda, you can directly take by lambda. That's it. That is the basic approach you have to follow with any kind of the logistic regression. And fit intercept, if you don't know any concept related to this, just go to and check this documentation. Penalty, dual, total, and the C weighted vector and the fit intercept, something called other things, class weight. So whenever you have imbalanced data set, we use class weight is equal to balance. Random state if you want to initialize randomly or not. So these are all the parameters. No one is going to remember these parameters, obviously, because we had tons of the parameters in the scikit-learn documentation. Whenever we need, we are going to be checked by the standard parameters like hyperparameter tuning, and somehow like class weight is going to balance. Whenever you get the imbalanced data set, at the time we're going to be check the documentations. Okay, so let's fine tune this. We are just fitting our model into the X train and also the Y train. What will happen if you just predict this model? So you can see if you predict this model, it consists of the zeros and one. That means whether the person is survived or not, it's going to be showcasing. But how does internally will happen? Let's go and check the probability values. So you'll also get the score, something score. You just ignore the F1 score as of now. Something score you got around 0.74. That is the 74 percentage you got. It's corresponding to the train data set. And what about the test data set? Corresponding to the test data set, you got around 75 percentage. This is slightly fitting of this model very brilliantly when compared to that. But 74 may not be satisfied with the end user, I can say. He needs somehow around 0.5 or above the 0.5. Yeah, so internally what will happen, it will predict some of the probabilities like this. It will be scaled between the 0, 1, as we just now discussed with corresponding this block, right? It will varies only the 0, 1. Yeah, you can see it will varies only the 0, 1. Whenever you see some unseen data point or outlier of the detection, it will convert into the 0.5 result. Somehow the probability value going to be showcased. We can also showcase as a coefficient of this matrix. Yeah, so yeah, you can ignore this KPI matrix as of now. We'll go and discuss that maybe later. I'm just explaining how does logistic regression is going to be helpful. For the coefficient, you can see this is varies like this. Whenever you have some of the coefficient with corresponding to the, you can say the logistic regression, it varies between the 0, 1 and also the negative results as we seen in this diagram. Some of the negative results going to be showcasing and the positive results going to be showcasing after completion of the 0.5 results. And you can also train by using future importance to get some of the future importance. I think we have done this. Yeah. So if you want to showcase more than you can say coefficient is greater than 0.3 results by using this plot, you can take that consideration and just give a plot like that. So I'm just taking the coefficient more than 0.3 results. I'm again plotting the same thing and again testing by using the logistic regression. And somehow we are going to be get the results like this. When compared to that plot, it is slightly very good, and the negative results are we are reducing when compared to that above the plot. So let's jump on to a project and try to implement this, and we will also get the feature importance according to that. Okay, so we have standard libraries like pre-processing steps by using the label encode and standard scalar. So these are some rescaling of the data. This is some feature engineering hack and logistic regression, and something called as a k-fold cross-validation technique and train test split. We are getting from all the from scikit-learn. Okay, so these are the KPI matrices. You can ignore as of now. We'll go and explain in detail maybe tomorrow or after tomorrow. Yeah, so see, we're just importing our CSV file as a data. So these are some of the raw data we have with corresponding missing values. So these are the major hacks to try to handle with corresponding to this data set. Something called as a gender having 512, 525, and also the dependent is and 2400, and the city also having 80 like this. So we need to impute or we need to identify or fix this issue. How to impute these missing values in this data set, and what are the different techniques we have. So if you take this gender, it is an ordinal column, obviously, whether it is a male or female. Then let's check how does that going to be helpful with regarding the male and female frequencies. The male frequency is around 60,000 and the female frequency is around 11,000. So according to this value, what we are going to do? So you have around, I can say, 5 to 525 values as a missing values. So how do you impute by using these frequencies? So one technique is you cannot be identify the missing values whether the person is a male or female. But by using the mode method, we cannot be identify whether he is a missing value is a male. So in this case, we can directly cause one solution here is whenever we don't know that much of integrity to understand like ordinal columns. you can directly impute something called as a -1 result. That -1 result going to be help us. We don't know the person having male or female identity. So at that reason, we just converted into the numerical value instead of taking only for the mode results or frequency of the male result. So most of the people will take as a mode results. Obviously, I can say that. But what will happen if you take the male results? It will model may not be works out well. The future importance is completely biased towards your male only, not with regarding the female, because we are calculating the distance between right the futures in the logistic regression model. So somehow we are going to be convert these male and female to the zeros and one, and we don't know about some other values like a missing values. We just replace it with a -1. So that's what we are doing, just replacing with -1. We use filno. Filna is a predefined function. We already discussed that in the Python videos. And yeah, just converting our ordinal codes with 1 comma zeros. If you just do that, it will directly convert and missing values to impute with -1. And similarly, dependence. So dependencies we have with corresponding the missing values. I think we have so many missing values in the dependencies. So let's go and discuss that. What are the different frequency terms we had? So you can see the most of the dependencies having very less frequency and only the few having very high frequency. This is a missing value. Obviously, you can see the 2 and the 1 having the more you can say more frequent kind of the thing. So in this situation, what exactly we had to do, we just fill with some of the values with zeros. So some of the values with zeros, because we don't know that much of integrity to identify, because this is also some numerical column. So we need to identify with that. Why not we go with the -1? So if you just apply with large set of the values, so you can see here, you have total around 20,000, right? So if you apply large set of the values with -1, it will completely bias towards our negative results. That means it can completely bias towards our churn prediction to automated to bias towards only the negative results, because logistic regression works with the positive and negative results at the end. It may not be calculated the majority vote other than the other models we had. And if you take somehow with regarding the zero, it may not be do any kind of the operation without some of the missing values. It will be only identify with somehow whatever the frequency of the other values we had. Because it having more less more number of the values, we have to reduce or we have to drop it maybe. But according to our data leakage problem, we cannot be do any kind of the dropping mechanisms. Anyhow, we can reduce by using the 0 comma 1 by using the standard scalar or the normalization, right? And occupation results also having very missing values, but these are the some frequencies. Self-employed having more you can say more frequent numbers when compared to the all. I think it had around around 8 and sorry around 80 only, right? So that's the reason we are just imputing. Sorry, around 80 only, right? So that's the reason we are just imputing. So you can see here, we're just imputing the self-employed with corresponding most frequent value we had in this column. Similarly, the city, we are just taking consideration for the mean value. So then it going imputing these distances. And the last transaction, we don't have any data. For that, we don't know whenever some person has a last transaction. So further, we just giving the dummy variable for the 999. So in this case, why we take as a 999? So we don't know about the dummy variable at the end. So if you just give it as a zero, so that does not make sense at all. If you give as something other dummy variable as a year, that will be very good. Eventually, all the people will try out with the 999 or 444. That is eventually works out. Even in my current project, also we are doing with the 999. Okay, so the data pre-processing with corresponding to our logistic regression. Obviously, the data pre-processing consists of the standard scalar. So whenever we do column standardization, that means future scaling, it will be works better if you directly apply the logistic regression. And somehow you can also reduce future integrity or future importance to get data from. So let's do that pre-processing steps what we had. And the occupation wise, it is a categorical variable. Just we have to convert to the somehow numerical wise. So what will happen if you just apply the one hot encoding? So this is also one interesting mechanisms if you tried with the categorical variables. So one hot encoding nothing but whenever you have a categorical variable, if suppose you have a categorical variable with red and color like green and some other color like orange, let's say. So these are the categorical variables in your data set. If you apply the one hot encoding, it will convert as a value to a column wise. That means it will convert F1 red. Whenever you get the value corresponding to the red value, it will become as a 1, and corresponding to the remaining all the values become as a 0. Similarly, it is also create another column with corresponding to the green, F1 green, and whenever you get as a green corresponding to that row wise, it will give as a 1 result. Other than all the values going to be give as a 0 kind of the results. So like that is going to be works out whenever we have active occupation is going to be somehow value. You can say this sample. Okay, so we haven't seen this sample. Okay, so let's also print that sample. Maybe I think we haven't print that sample, but in having some of the values with corresponding to the occupation, it will go and identify with corresponding to the whatever the different values we have. The get dummies is nothing but we're just creating some of the dummies according to our values what we had just seen in this example, red, green, and also the blue like that. So for the numerical, we just apply the standard scaler. This is the best mechanisms to rescaling of data. Okay, then we can also analyze by using whether we have to apply any transformation techniques to rescaling of the data with respect to ordinal or categorical variables. So, yeah, so these are all the numerical columns we had in our data set. We're just taking as a list. We are just looping together to identify by using our lag transformation. Then we can also applying with the standard scalar technique to minimize our linear transformation from non-linear to linear transformation technique. So we are taking and we are merging our data frames. This is a scale data frame we are merging with our categorical data frame, what we just now imputed with the one hot encoding. Okay, so let's go and implement our logistic regression model in this data set after completion of the some of the pre-processing and the missing value imputation. We have so many mechanisms. I can say we are all this skipped out, like outlier detection, some of the missing values to impute with the KNN imputer. But this is a small toy kind of project, I can say, with corresponding to the logistic regression. Okay, so we are taking into consideration of the churn prediction as train target variable, and we are just dropping somehow unused, you can say somehow not that much of usefulness in the modeling perspective, like customer diaries and some of the occupations. So let's build our baseline model corresponding to whatever the columns we had. So these are the columns we are just corresponding to after completion of the standard scalar and also the one hot encoding. So let's define our logistic regression model and train by using without any hyperparameter tuning or anyhow some reducing feature balancing, or you can say forward feature selection or the backward feature selection. We'll come across with that whenever we encounter with some of the feature interpretability showcase. So just train that on how to get the matrix. This is also one of the best matrix I can say, AUC ROC results to train somehow, and it will also give the good results with the corresponding to the TPR and the FPR matrices. So let's take assume something called something score called as 0.7 result. Okay, and similarly we have seen with this example F1 score. So let's take this example as a 0.7 results according to just for understanding of the logistic regression model. So this is the trained data set, and for the test data set, we are going to be get as around recall. This is a recall matrix around 0.12 result. So this is the 12% we recall. 12% is the false negative results we have. So we have somehow to reduce. This is also one of the good matrix called as a confusion matrix or accuracy results. Yeah, so let's jump on to this something called as cross validation technique. So cross validation technique, it's going to be help us. So whenever you have let's take this example maybe. Yeah, so Cross validation technique, whenever you have a large number of the trained data sets, okay, large number of the trained data sets, you just divide it into some iteration process. You want to be do some of the iteration process, and you just divide it into the trained samples around and also the test samples around. You wanted to keep iterating yourself to minimize the trained samples 80% to 20% or 70% to 30%, like that. So if you're going to be try with threefold cross validation technique, it will keep iterating the three times with according to the trained samples and also the test samples. And whenever you try it with somehow with 70% or 30%, it will keep iterating with somehow reducing the test samples and also the trained samples. Like we just we come across with something called as a cross validation, right? We have not seen the data when we are training somehow the results. You have split it into the train and also the test and also the cross validation. So this is a cross validation results where you haven't done any kind of training results with corresponding to the data points. Obviously this is unseen data points. So whenever you do something called as a k-fold cross validation or stratified cross validation technique, it will keep iterating with regarding the train and the test samples without any doing the cross validation data sets. So we just performing on this data set because we need to identify how does that going to be helpful with the unseen data points. We are getting somehow around the results around zero point 0.7, but how does that going to be help us in the cross validation data sets? So currently we are using k-fold cross validation technique with five-fold. So it will keep iterating with the five and the five times. Okay, it will keep iterating the five times. It also get rid of from the AUC results and also the recall matrices and precision matrices. So obviously the precision and recall going to be high and anyhow. So we are going to be check with some of the slightly improvement with corresponding to the AOC ROC. So currently we are using k-fold cross validation technique with five-fold. So it will keep iterating with the five and the five times. Okay, it will keep iterating the five times. It also get rid of from the AUC results and also the recall matrices and precision matrices. So obviously the precision and recall going to be high and anyhow. So we are going to be check with some of the slightly improvement with corresponding to the AOC ROC results. So if you take maybe we are just taking somehow, I think for the baseline columns, what we just now discovered with the baseline columns. We are not taking all the features. This is a somehow baseline models we are doing be trained corresponding to the k-fold cross validation technique. We can also do with maybe all the features. So with this all the feature we are just training around, we are getting 0.78. So somehow slightly improving with corresponding to the if you just apply with all the values. So what will happen if you do something called as a feature importance? So in this feature importance, we have two mechanisms. One is forward feature selection, another one is a backward feature selection. So let me explain this with you. How does a forward and the backward feature selection going to be help us? So in this image, you can see we have all the features. This is the you can say all the features we have in this spot. So you're going to be take all the features and recompute by using any model. What will happen if you take any feature and do some modeling, you will get somehow accuracy results or AUC results or a score. Let's take some score. You will get a score called 0.8 for this, and for this 0.7, for this 0.6, for this 0.5, for this 0.3. So whichever having the highest score, we are going and take consider into our model. Okay, so currently we are using X2 is having more higher value when compared to the all other features. So we are just combining this into our model. Whichever having another high frequency or another high score, then we can combine to the other. So like that, we are just combining with together corresponding to the model evaluation what we had. So that is the reason we are just following as a forwardly we are taking a feature and combining together in our modeling. So most frequently is going to be combined together at the end, but lesser number of the score it may not be identified. Only we are going to twinkle to take only for the 5 variables or the 10 variables according to our requirement. And something called as a backward feature selection. This is a reverse of operator when we had to combine with somehow feature with other. It what exactly is going to be do? We are going to be eliminate somehow whatever all the corresponding models we have. So we are going to be trained with somehow model corresponding to the x1 and also the x2, x3, x4, x5. So whichever having the low score, whichever having the very less score, it's going to be identified and it's going to be removed to our data set. So like that is going to be works out. But the major disadvantage with respect to the forward direction is we are going to be calculate twice, because we are going to be calculate at the data set side and also calculate at the model side. So this is very time taking process when compared to the backward feature selection. We are directly calculating at once in the model side and we're just removing or throwing out into our data set. So in this project also, we are going to be take consideration as a backward feature selection, or we can also call it as a feature elimination process, reverse feature elimination process. So it will take less time when we are applying the large data sets while doing the logistic regression. So that is a major factor to take, you can say, elimination backward feature selection. So let's tie with that with corresponding our logistic regression what we had. So this is a basic syntax for the, you can say, reverse feature engineering technique. We will also get it from the scikit-learn. Feature selection, under feature selection, we will get it from reverse process or reverse feature engineering library. I can say it will takes around half an hour to compute this cell. Okay, the total cell having more number of the features we are going to be evaluated. But corresponding, we are just taking only for logistic regression we have just applied on the top. Yeah, so these are the number of parameters in the, you can say, reverse feature engineering process. Also you can also apply maybe the estimator to predict any kind of the model. Currently we are using logistic regression only. You can use maybe the other models if you want, and hyperparameter tuning, class weight, number of the iterations you want to be specified to compute or recompute your features, and then you eventually get the future importance according to the ranking. So let's go and print with the ranking. I'm just printing the rank according to the future results. So you can see current balance having the rank first. That means the current balance holding the very future importance while doing some modeling, and average monthly balance and occupancy company. These are the some top 10 future or top 20 future we are going to be identified according to our estimator. Currently, we are using logistic regression. That is also very interpretable of the model. But whenever you apply some tree-based mechanisms, you can identify with respect to that. And also you have to fine tune your hyperparameter to compute very faster. So take top 10 features and recompute our logistic regression with k-fold cross-validation technique. Then how come our ROC results or some score we are going to be get? At some point we get around 0.78. I hope you remember, but at this situation we are going to be get 0.7 and slightly improving. You can also get at the k-fold fourth fold you're going to be get as 80 result. So like that is slightly improving. You can also see the second fold is going to be get as 81. So take the top 10 features and apply to our all the features what we had instead of taking only corresponding features. So in this case, you can directly apply with all the features. Eventually with the same results, you can also see eventually we are going to be take the same result. I think we are going to be take consideration for all the features. Yeah, so let's also compare with all the features according to our top 10 features what we had. So you can see at the time of second for cost validation result and the first for cost validation results, all the top 10 features having holding the very future importance when compared to the all, and the model accuracy is also very high when compared to that. So around 0.881, right? So around 0.81 results we are going to be get at the top of k-fold cross validation. So like this, we have to tune. You can also try with the forward feature selection along with k-fold cross validation technique. So I will also send you a reference notebook with corresponding to the hyperparameter tuning. You can also fine tune your C. So this is also very good matrix to fine tune to get rid of. You can also try with penalty to change L1. What exactly the results will happen, and why we are take consideration by default as L2 instead of taking as L1. So you can also play around with this data set. I can say when come just ignore as of now the KPI matrices we are just calculating as a score. Yeah, okay, let me share my screen. Yeah, so we're going to discuss today on the NLP related concepts along with some some ED analysis with Matplotlib with coronavirus data sets. So these are some of the sample data sets we have taken from Kaggle only. So you can also, I will also share with this CSV files or some of the Excel files what we had. You can also practice well by using some of the Matplotlibs. So we'll come this notebook again maybe. So let's go and understand some of the NLP related concepts with regarding the tokenization mechanisms. So tokenization is a process to convert from text to integer or text to a number. So what will happen, you can say, so I hope you know something related to the computer science. Computer will learn only the numbers, that is zeros and ones. It may not be learns any integers or any, it may not be learns any kind of the strings or any kind of the categorical values. So you have to convert from whatever the string formats or whatever the categorical formats to the numerical side. So that is the reason we need to convert any kind of the strings or any kind of the text you're going to be get from the data to the integer. So for this process, we can also call it as a tokenization. In that manner, we can also divide it with some of the other algorithm to utilize it. And what will happen if you tokenize the sentence? Suppose you have a sentence like this. This is this is a statement like that. You have a some sentence like this. So this sentence you want to convert to a numerical vector. So I hope you know, right? Something called as a vector we already learned in the 11th and 12th grade. It having some of the collection of the elements with corresponding to that. So what will happen when you have a sentence? It will divide it into a words. So this is a word. We can also call it as a some value for this. We can also assign to some value according to that. And the statement is also converted to some value. So like this going to be divided has a three words. You can say as a sentence. We can also call it as a document for the NLP context. Document. So for all collection of the sentence, we can call it as a corpus. Collection of the sentence, we can call it as a corpus, and collection of the words, we can call it as a document. And we will get the we will get the words after completion of the tokenization, or you can say splitting of the sentences into the word. So these words can be converted into a vector. So if it is going to be converted into the one, the each and unique word, you can say each and unique word is going to be converted to some kind of the value assigned to that. So what are the different ways to assign a value? So that is also one question in your head. So we have so many techniques to do that. Something called as a bag of words, and something called as a TF-IDF, something called as a word to vec, average word to vec, and weighted average word to vec. So we have so many other methods like BERT model we can also use, that is most popular nowadays. So let's go and check out how does bag of words is going to help us understand in terms of text to a integer. So bag of words, the concept is came from, we have a unique value, sorry, we have a unique records in your document corpus. So if you found any unique words, it's going to be converted into dimensionality vector by using the each and every word. So let's take this example maybe. So this car drives good and is expensive. This car is not expensive and drives good. So in this sentence, you can see this is coming two times for the both sentences. Car is coming from the two times. Is not there for the first sentence. Not is also not there. So whatever the unique words or whatever the common words you can say, so that will comes in a dictionary. You can see that will comes in a dictionary. It may not be repeat that again and again. So this is coming for once, car is coming from once, drives coming for once, good is coming from once, and is coming from once. Whatever the unique records or whatever the unique words we have from these two sentences, it's going to be divided like this, like a words in a list. Then how does it going to be create a vector? So that is other question, right? Just now we spoken about that. How does it going to be created as a vector, assigning each and every word to some value? So how does that going to be represented in the bag of words means every document is going to be created as a some dimensionality or a vector according to each and every word. What will happen if I assign some value to this, and what will happen if I assign value to car? So like that is going to be works out. And whenever you need some of the value around every dimensional, that is going to be equal to the number of occurrences of the unique word. If suppose this is coming from 2 times, the number of occurrences we have to give that according to the respective word. Similarly, the car, similarly the drive, whatever the occurrences of the unique word, we have to prefer and give that value. So yeah, you can see like this is going to be get. You're going to be get for first word. We can say the first sentence is what we had. Yeah, you can see the first sentence. This car drives is expensive. This car is not expensive drive. That's going to be converted as a one vector. That is a V1. And secondly, we're going to be converted as a second vector as a V2. So these vectors going to be represented like this in the, you can say, embedding matrices or embedding vectors to do any kind of modeling mechanisms or visualization things. So I can say bag of words is going to be helpful only whenever you have some of the words are occurring. So it may not be preserved. It may not be preserved. Something called as semantic meaning. That means if suppose I have a word like you can say some tasty. So tasty and delicious. Delicious. So like this, I have a word tasty and delicious. These are the both words similar kind of the meaning, holding similar kind of the meaning, right? At my perspective, but as a system perspective, it may not be identified that. That means it may not be holding the semantic meaning. It will just allocating each and every word for some vector or some value according to that. If suppose I got a value for 1 for this, I got a value for 0 for this. So according to that, I get some values, but it may not be preserved. These two values or these two words are the same. So at the time, it may be confusion between the bag of words. So that is a major disadvantage with the bag of words. So we come over with other techniques to hand over the semantic meaning. So yeah, it will obviously compute some of the distance between the each and every word. Okay, between the each and every word, if you're going to be compute the distances, you will get whether it is coming, you can say whether it is coming near or forest far. Then according to it's going to be give some value to that. So similarity wise, bag of words is better when compared to the semantic wise. It may not be helpful. So that is a major value to that. So similarity wise, bag of words is better when compared to the semantic wise. It may not be helpful. So that is a major disadvantage with the bag of words. So we can also represent by using the zeros and ones. Whenever the occurrences of the word is came, we can represent as a one. Otherwise, it's going to be a zero value. So let's also implement by using the scikit-learn. You can see here we are just exporting from the feature extraction. We can also call it as a feature engineering hacks for the NLP context instead of calling the tokenization mechanism. Feature engineering hacks for the NLP related or test class classification task. So we are just extracting from scikit-learn count tokenizer. It will count all whatever all the unique words we have in a sentences. Currently, we are taking some corpus here. You can see we're taking the same example as a corpus. That means a collection of some of the statements. So we are fitting some corpus to understand the count vectorization has a function, predefined function from scikit-learn. We are taking some variable called CV. So it will create and it will hold some of the unique values, whatever the corpus value we have available. You can see each and every value assigned to some unique value. Each and everything. Just now I told about how does that going to be preserve some of the values in a vectors, like some unique value assigned to the each and every word. So this representation is going to be helpful whenever you do some modeling. Okay, so you will you want to know about some of the unique values from the sentence. You can directly use this get futures name. You will get all the unique words whatever available in there. and you want to represent it in terms of array format, you can fit and transform. Here also you can do the fit and transform. So instead of that, just for understanding, I just given here to do know about the some of the transform to understand whether it's working fine for array wise or vector wise. Yeah, so you can also read this. So and is coming from once and is coming from second. For the seconds in statement, better is also same. It is this. So these are all going to be help us whenever the occurrences came with the bag of words concept. Yeah, just some of the advantages and disadvantages. It may not be hold the semantic meaning. That's one disadvantages. And it will count some of the different words between some of the vectors like tasty and the delicious. It may not be works out with semantic meaning whenever you want to consider. And some cases, what will happen? You have to do removing some of the stop words. At that time, what will happen if you remove some of the stop words? It may not be hold that much of prioritize, or you can say it may not be hold that much of containing that much of information in the data sets. Stop words is nothing but you have something called as has or is or this. So these are some of the stop words. We have so many stop words, around 90 to 100. So we have to remove this. So at that time, what will happen if you're doing some modeling, it may not be hold any kind of the meaning, because these are some, you can say these are some representing of some other items or some other places maybe, but it may not be preserved that much of vocabulary kind of thing or verb kind of the thing. So at that time we have to remove some of the stop words. So when you remove some of the stop words, bag of words may not be preserved. The idea is you cannot be do all the stop words. You have to do only the few stop words. So at that time it's going to be works out. Otherwise, it may not be that much of integrated to understand bag of words completely. So for that we have another technique called TF-IDF. So TF-IDF is slightly better than the bag of words, but similarly, this is also some of the advantages with respect to the bag of words what we had. It's still not holding any semantic meaning, but we have to slightly increasing some of the, you can say, accurate values when compared to the bag of words. So the definition wise, you can see we have something called as a term frequency. We have two terms here. One is a TF and another is IDF. So TF is a term frequency with corresponding to this formula, number of occurrences of a word. That means total number of the words what we had in a corpus or a sentence. Then we are just dividing with the total number of the words in the document, or you can say total in the sentence. So that will preserve some value, obviously, and we are multiplying with this value, IDF value. That means a log of n by small n. Total number of the documents, that means total number of sentences what we had, along with total number of number of the documents in which the word is occurring. If suppose you are just working with some word like tasty, so it's going to be occurred only once or two times, so it will print the two times here in the denominator. So in the numerator is going to be get the total number of the documents, how many documents you have, how many sentences you have, then it calculate the log value and multiply it with the TF results what you have. So that is a formula for this TF IDF. Okay, you can also remember this whenever the required. Yeah, so yeah, this is a formula. You will also get at the end as a vector, obviously, for this. It will hold some other, instead of taking some occurrences, that is a basic idea here. So just now I told you, this is the idea how to take the values, how to preserve the values by using some words. So instead of taking in bag of words, we are just taking has occurrences values. In TF-IDF, we are just calculating some formula method by using the log. We are going to be preserve some value like around 0.5 or 0.7 like that. So these values is going to be help us to understand for each and every word have a unique value at the time, because we are taking at the occurrences, right? We are taking at the occurrences by total number of occurrences by whenever the word is presented. So we can also implement by using any sample data set. We can also try with maybe the next class we're going to be discussed with Amazon Fine-Food reviews. The data set is very large. Yeah, similarly, we will also get it from the scikit-learn feature extraction. TF-IDF vectorizer. This is also similarly back-up you can do this. Even Word2Vec also. Yeah, you can see we're just directly doing the fit and transform to understand about what are the different unique common words we have occurring between the in a sentence. Yeah, so you can see all the values in somewhat dimensional. They are all the values in somewhat rescaling up some of the values. We instead of getting the ones and zeros, we're getting some values because of the log value. This is how this is going to be represented. We cannot be understood because the formula is going to be looks like this, right? TF into the IDF, the value going to be calculated at the end. Obviously, it's going to be belongs to in the range of 0, 1. It may not be preserved above the 1. You will get less value is 0, and above the 1 you may not be get, only below the 1 you will not be get. So like that is going to be store some of the results, okay, at the end. And this is also still may not be preserved the semantic meaning. If I have a value called tasty and delicious again, it will give some value, but it may not be hold the same meaning according to that. So that is one disadvantage with respect to the TF-IDF. Just a second. Yeah, so yeah, it will also may not be helpful that. So for that we have technique called Word2Vec model. So what exactly the Word2Vec model does, and what are the different terminology we are going to be so, and how does it going to be preserve the semantic meaning? So this is the deep learning mechanism, I can say. Whenever we learn some of the basic concepts about the deep learning, I will explain in detail. But as of now, I will explain you how does this going to be works out internally and what are the different terminology we are going to be showcased. So this is related to neural networks plus backpropagation algorithm. We can also learn something called as MLP, and where we're going to be use all the other matrices we are going to be used at the end, and some of the cell states and some of the nodes by relu activation functions. At the time, that may be make sense to you to understand instead of learning just for a concept. So this is going to be represented whenever you have some sentence. It's going to be split into the words, and then what will happen? It will convert into the dimensionality. Similarly, we have seen in the TF-IDF vectorizer, and whatever the similar kind of the words you can see in this example, whatever the similar kind of the words, it will hold some of the distance between both of them, or you can say it will calculate some of the distance between both of them, and it will, if suppose it is very far away to this value, it may not be interacted, it may not be grouped together. If it is a very somewhat you can somewhat near to the distance, it will go and group it together, and it makes as a similar kind of the meaning, or it makes as a some kind of relationship between this point to this point, like that. Similarly, this point to this point, like we have a word called king along with the queen, so it has holding some of the relationship between both of them. So you can see this word walking and walked out, both the meanings is same, right, for a verb or noun wise. So if you take this consideration, it will group together and gives as a only one vector, instead of taking only the two vectors or two dimensions of any kind of the vector. Similarly, you can see the Spain is related to Maryland, some of the states wise and also the countries wise. It holds some of the meaning. So it will get it from something called as transfer learning also. We are going to be get it from the, you can say, you have some data frame already trained. Instead of just listening, you have already a frame. Someone is already a trained large number of the parameters, like they have trained around 20 billion Wikipedia pages and 10,000 billion books. So you have a huge amount of parameters to train some data frame. Why not to use that? You have to use this. So you have to use this, you have to apply to your NLP context, because what will happen if you cannot use this, even system does not understand your language, what exactly you are speaking, English speaking, what exactly you are English speaking, it may not be understood, because unless until you cannot provide the large data sets, it may not be understood that much of integrated to any kind of the mechanisms you want to retrieve. So we have already predefined models called Google News. We have the Google News with recordings, large number of the parameters to train already, and something called as a glove vectors. So this will hold some of the meaning around with the relationship between some of the words like this king or queen or man or woman. It's already trained. It's already trained by using some other good universities or some other good organization, big four organizations maybe. So they already implemented this solution. We had to call these data frames, or we had to call these functions whenever we required to do any kind of word to vec model. So for that, we need to understand something called as a deep learning mechanisms, and we can also go with back propagation mechanism. How does it going to be works out? Along with, we can also learn transfer learning. So this is nothing but a transfer learning. Someone is already learn, or someone is already implemented a solution. You have just want to retrieve that API, or you want to just retrieve from the data sets. So for that, we can call it as a transfer learning. Someone is already learn, or someone is already implemented a solution. You have just want to retrieve that API, or you want to just retrieve from the data sets. So for that, we can call it as a transfer learning. So we're going to see in the maybe in the deep learning concepts whenever we are going to be showcased. So as of now, we're going to be explained up to some functionality. How does that going to be works out? So similarly, we have called as average word to vec and TF-IDF with weighted average word to vec. So this is some extension with regarding the TF-IDF and also the word to vec model. So just taking some average according to the word to vec mechanisms what we've seen, and just taking the average according to the all the data points and how many, you can say all the words, whatever the words, unique words we have in the corpus. Similarly, the TF-IDF weighted weight, sometimes it's going to be works out okay. So you have tried backup words, you have tried TF-IDF and word to vec. So you're not satisfied with your results. So at that time, you can use these extensions. That is the reason I'm just explaining you. So we can also use these extensions in the maybe the Amazon Find Food reviews, maybe in the tomorrow, so that you will get some clarify. How does this going to be help us to improve our accurate values? So here also we're just taking averaging of TF-IDF weighted word to vec instead of taking only the word to vec model average. So just applying the TF term here to multiply with the word to vec model. Okay, so let's go and discuss with maybe this matplotlib. How does matplotlib is going to be help us in the EDA analysis? I've just taken the novel data frame so that it's going to be help us. So you already know about some of the data. How does that going to be looks like? We have a state or countries and confirmed cases, some foreign nationals or not, queried cases or death or confirmed cases. So you can also retrieve this data sets from Kaggle. If you go to the Kaggle, maybe you will get tons of the data sets. Not only this, you can also play around with this Kaggle COVID data sets. Yeah, data sets. You go and type. Yeah, you will get tons of the data sets like this. You can also search by using the filters option in this Kaggle itself. Yeah, here is a one again. You can see here is a one again. You can also download this, some of the countries, confirmed cases, the death and recovery. You can also download and play around whatever the matplotlib consists of or documentations what we had. Then that's going to be helpful. You can also directly search here COVID-19 or maybe like that, like a keyword. So you will get something filter options here. Comments you want to check or notebooks or data sets. Just click on the data sets. You will get all the related filters also. If you want, you can also apply the CSV files or Excel files. You will get all the data sets. Tons of the data sets. Even Google data sets also there. If you go and search Google data sets, you will get some of the data from different sources. So they only implemented from 2020 Google datasets. Okay, so this is from research side. If you go to this link, you can see, you can search anything, you will get the Google datasets. Suppose I want to search COVID-19, you will get all the results according to, maybe it's not learning. Okay, Yeah, hyphen is there. Yeah, you can see here tons of the resources from the different organizations they were going to be implemented with regarding their research or their citations they want to be understood. You can also filter by using any start updates. So that's how you can download anyone you want with regarding any kind of the keyword you want to mention it. So let's go and discuss this. So we have four data frames here. You can see individual details, COVID-19 India, and also ISPs on the data sheet. I have some other Excel sheet we had. So yeah, you can see this is COVID-19 data sets. Yeah, let's play around with this. Yeah, we don't have any missing value on this. That is cool. Yeah, so I just want to know about how much confirmed cases and death cases for this date, July 1st on 2020. So just want to display that. I will also perform some of the operations. What are the confirmed cases? So I just want to retrieve the data. What is the latest data? And I just given the some date. You can also play around with our current date and what are the different. You can say you can also make it as a greater than so that it will get how much data it is came from, and we got from 2019, right? You can also get it from 2019 maybe. You will also filter by using greater than and also the less than in between the dates, and you can play around with the confirmed cases what we have. You can also play around with the some statistics. How does the confirmed cases percentage or in that region, how many the cases are cured, how many deaths and when compared to the cured cases, and what are the confirmed cases, what are the non-confirmed cases. So many things you have to do by using the statistics whenever you have some of the data sets. Okay, so let's go and visualize the things by using the matplotlib. So I have taken only the date, whatever we have seen as a July 1st date. So let's play around with that. I'm just sorting some of the values with the confirmed cases. You can see I'm just storing as a data frame. So in this data frame, I'm just taking the state and also the union territory. This is a column name we had, state you can say. So I'm just taking the top 5 columns. Okay, so and the data set we're just showcasing as a confirmed cases, and just this is all the parameters. Okay, so you want to color it out or you want to align it center, maybe median or the left side. That's your wish. Yeah, these are also very helpful parameters like labeling at the title. You want to add some legends, you can get it from the documentation only. The show you want to show it. Figure size also, some of the cases figure size is also going to be helpful. You want to visualize how much type figure size. Yeah, you can see this conformed cases mostly in the Maharashtra side when compared to the all the states. And what is the value and what is the percentage of the value? How does the difference between the other states? You can also calculate and write some English ways. So just now, I think yesterday also I told this to write how to write these things and what are the different ways to write in a simple English so that someone will go into understand. If the end users may not be a technical guy, he will obviously go into understand these Englishes only. Unless until you cannot be show this English, it may not be possible to get the idea, and it may not be possible to get the based on the decision they want to make on. If you are a business, some project related to the Amazon, so the find for reviews, we are going to be predict the rating by using the reviews. So let's understand this perspective. What is the machine learning life cycle and what are the different steps we are going to be handled with this? So yeah, in this image you can understand these are some of the steps we are going to be follow. I hope I'm audible, right? Firstly, hello. Hello, I'm audible. Okay, cool. Thank you. So let's first go through these steps, and then we can also discuss the tokenization mechanisms. How does that going to be work? So we have learned yesterday with regarding some of the bag of goods, and you can say TF-IDF and word-to-vec models. So how does it going to be works out? We can see that maybe later. So here you can see we have something called as a problem definition or the problem to understand or the basic business constraint we are going to be take consideration. So what exactly this step does, whenever you encounter the problem definition, here you have to be configured or you have to be somehow you have to understand the business domain knowledge. So we already discussed maybe in the PPT. at the time of beginning of these classes. So I hope you remember where we discussed about some of the domain knowledge we require to understand any kind of the problem specificness or the problem constraints we are going to be follow with that. And you have to more focus on the business statements. We can also call it as a BRD for that matter. Business requirement documentation. We have to prepare whenever you have to be enter into the project or whenever you accept some of the project by using the BRD. So the constraints we are going to be follow up with, I can say the standard constraints for a machine learning problem, something called as a low latency requirement. That means we had to hand over this project within, I mean, you can say the prediction or the merit classification you have to be solved. That is going to be compared with within milliseconds of the time to compute 0.0000 maybe one. This much of milliseconds of the time we have to compute the predictions or the classification task. So no one is going to be wait for 5 minutes. If you go and open the YouTube or maybe the Google Chrome, no one is going to be wait for 5 minutes to load. That's how our human kind of the kind going to be generated nowadays. No one is able to wait for some time to reload, and maybe the asking for some classification to the task or maybe the prediction to the task. So we require some of the low latency requirement. You can also see some legacy systems are not popular with the low latency requirement. You have to wait for some time to get the results. So, and another constraints most probably we're going to be get as errors are more costly here, because you have to minimize the errors. You have to minimize the errors whenever you have accepted the BRD. You have to minimize the errors. You have to handle all the cases, not only the one case. You have to handle whether the data is missing, what will happen, and what is the interpretability of the model. I mean, you have to showcase to them what is the feature ability you're going to be learned by using your model or trained data sets or the test data sets. What is the interpretability of the model? And you have to explain them what happens if we don't have the data. What happens if we don't have the data? Some sensor data, you can say, if you take some sensor data, you predicted some model by using the sensor data, but what will happen? Sensor will shut down at the time, at the some point of time. The model may not be learned that. You have to be hand over with that. You have to be maintain the another sensor data with regarding some historical data maybe at the time. Historical data, or you can say legacy data for that matter. So these comes under all the sanity check you have to handle over with the error minimization or loss minimization. You have to come over with your model whenever you're doing some problem statements. So this is the things we have to handle in the business definition. You can say the problem statement you have to be handled with the machine learning perspective. So in the next section, you can see the data selection. So you have tons of the data types. So not only the categorical or not only the numerical or the ordinal or the text data. So you have audio data, video data, sensor data we have just now seen. So tons of the different types of the formats we are going to be seeing in the data selection wise. So how do you handle with that raw data? First point. And what are the different techniques to handle with regarding this? So some of the companies may use as a big data technologies. Some of the companies directly only use the PySpark. So PySpark is going to be help us at the time you are handling with the raw data. You can convert into the delta tables if you are using the Databricks. Delta tables is going to be very faster when compared to the normal data sets we have, data frames. So in the data selection, that depends on the data architect. They're going to be provide some references. You can say how to handle with the raw data or the big data technologies you have to use or not. So that is up to the data engineer role. Okay. So we have so many roles in the data science. Not only the data scientist, we have data engineer, data scientist, data analyst, business analyst. Each and everyone having their own requirements or own satisfying the rules and responsibility they're going to do. So if you take consideration for the data selection perspective also, we had role called data engineer. The data engineer will do how to handle the data and how to get the data from the Oracle side, or you can say some SQL side at the end of the source, you can say. Yeah, this is the trick part. whenever you want to do some kind of the ED analysis, exploratory data analysis. So this is our part. I mean, whether you have a data scientist or the data analyst, even you had a data engineer also, you have to do some ED analysis. According to our knowledge, we already some learn something called as Matplotlib and the Seaborn libraries, how to do some kind of the visualization stuff, right? So by using that, what are the raw insights you're going to be getting? So you have a raw data. So you have to give by using some Matplotlib and SNN or the Seaborn, you can say. So by using these libraries, or you can also use maybe the Power BI for the visualization perspective, or you can also use Excel even if you are familiar with Excel. So these tools is going to be help us to visualize the things, and it is also give the business insights. Business insight. This is a more eventual decision taking process perspective, you can say. Decision taking perspective whenever you are learning any kind of the stuff from the exploratory data analysis. So most of the you can say most of the interviews also mostly focus on the exploratory data analysis. How does you have learned from your raw data sets, and what are the different things you are going to be encounter in the insights of the data. Whether it is a text also, you have to handle it with some of the text classifications techniques or text analytics by using the ED analysis. So the next step is going to be data pre-processing. What will happen in the data pre-processing steps? So we already learned something called as a missing values to handle out whenever we learn the some case study, right? So missing values 200, and we haven't learned, I think, outlier detection. This is also comes under the data pre-processing steps. So yesterday we also seen how to tokenize the things, and you can see to clean the any text, whether in terms of you have some special characters, and you can also have some emojis in your text data. So in this case, it's all comes under the data cleaning and the pre-processing steps. So these steps is also mostly work on with the data scientist and also the data analyst work. And sorry, no, not only the data analyst may not be use the pre-processing steps, but data scientist must be use this data cleaning and also the pre-processing steps. Then he will went to do some transformation techniques or the feature selection techniques. These are up to us. So we have so many mechanisms to do this. We can do based on our data sets and also the decision make upon the BRD, whatever the BRD we have done. So comes under the model selection again, which model is going to be pick up. So we have so many models. We have thousands or tons of the models in the machine learning. How many models we are going to be pick up, and what are the different scales to handle over with our big data. That is also one of the problem. So training of the model, testing of the model, model evaluation, these are all just for understanding purpose. We can also see this maybe in the upcoming case studies. How does we going to be works out with the model selection and the training model. So deployment. So obviously once you've done any kind of the model, how to deploy this to showcase to the end user. So we have so many, I can say, frameworks. We have so many frameworks. We can also deploy by using the Flask. We can also deploy by using the Django and something called as a Streamlit. And we can also use Heroku Cloud. So these are some free source libraries we have to use, and open source I can also call it as. And we can also use maybe the cloud environments. Cloud environment. I hope you're aware about some of the cloud environments like AWS, Azure, and also the GCP. So these cloud environment is going to be help us to going to understand. If the end users may not be a technical guy, he will obviously going to understand these Englishes only. Unless until you cannot be show this English, it may not be possible to get the idea. It may not be possible to get the based on the decision they want to make on if you are a business analyst or data analyst. Okay, so similarly, the debts also you can calculate the debts by using our just a bar plot. This is just a bar plot, right? You can also visualize by using different colors. Currently, we are using some grayscale. You can also use different colors. Similarly, the debts also very increasing between the you can say Maharashtra side when compared to the all, and you can see the confirmed cases by the death cases we are going to be get as some percentile. You can say some uh, death by some confirmed cases. This is some logic to understand whenever you have some profit loss, or you can say you want to know about some ratio. So you just calculate by dividing with, you can just multiplying with 100 and divide with the total number, right? So that's how you can also do some logics whenever you want to do any kind of new column or new data frame according to that. So I'm just creating the new column like death by number of the cases has on such date, and you can also see we are just giving the divided with the two columns, and rounding is nothing but just taking the only two according to the two decimal point. So we are just rounding up if it is any decimal value. Yeah, in the next line what we are doing, we are just taking whatever the value from this data frame, and this is the column we are going to be get, right? So I'm just rounding up whatever the floating value we had. The floating value is going to be less than that or may not be less than that. I'm just sorting ascending order, and these are the top 10 values or the head values we're going to be get. So mostly the Gujarat having, yeah, we are using ascending, right? So the mostly maybe Pondicherry. Yeah, so the Pondicherry having 59 percentage of the death by confirmed cases when compared to the all, right? And you can see, and yeah, this one is the less when compared to the all, but I'm just curious to understand this is somewhat mid-range of the cases when compared to the all the cases. So if you take average also for this percentage, you will get idea what are the average cases or average death by confirmed cases for each region or each states. So these are the most I can say this region, these four data frames are going to be average kind of the thing when compared to the quoted deaths and also the confirmed cases. You can see that death and confirmed cases are very less when compared to this, but it's slightly not that much of integrity to make sense when compared to this. So that's what I'm thinking. So it may be replicate to all the other states maybe. And you can see I'm just taking the 10 million instead of taking only for the such date. So you can also play around with 1 million maybe, or you can also play around with the 2 million. How does that going to be helpful in the other different states we had the corresponding the cases. So this is the another data frame we're going to be get Indian states. So let's go and check out that. We have, I think, CSV file only. Yeah, sorry, this is in the Excel file sheet 1. So in this Indian states, yeah, we have this data frame. State wise Aadhaar card is assigned as of now 2019, and along with the area per square kilometers. So how much the kilometer for the area according to the state. So that's for the information and assign some of the other cards. So we'll rename some of the columns. This may not be looks like. You can also see some of the columns are having some spaces. So whenever you want to do some like this, so whenever you want to do some of the new columns, you have to renaming, or you may not be. You can also make something like underscores. That is also very helpful. And instead of that, you can also rename the things if possible to do that. Yeah, you can see we're just renaming the things according to that states and also the population wise. So instead of taking the other card, we're just taking only the population and also the state wise. Yeah, you can understand by using this data frame maybe. So what are the different populations we are going to be get, and we're just displaying on the head. You can also display up to how many states we had. I think we have 27 states, right? So you can display all the states. So according to that, you can do analyze, or you can also sort by using the descending or ascending order. You can also take maybe what is the mean value according to the states, and you can also perform the percentile value according to this state to other state, and what is the increaseness percentage or what is the decreaseness percentage. That is also helpful to understand how many cases are increasing at this stage when the populations are increasing. So you can join with the other tables. We had already tables with the death and confirmed cases, right? You can join with this table to try to understand what is the population between these two tables and how much the death is increasing every day. You can also play around with the month wise or the year wise. You can also do some percentile wise and the statistics to get to know about what is the mean value corresponding to the each and every state. So we had to do so many things by using the Python instead of going with the Power BI or instead of going with the Excel. Python will helpful to understand whatever the possibilities where you have to do. So that is the main strategy to follow any Python coder or any kind of the developer, because every time what will happen, you have a strategy, but you don't know how to implement it. If you have some Power BI, so Power BI only makes us some columns and rows, but it may not be makes us to understand modeling. You have a modeling in Power BI, but you cannot be do eventually from scratch. You have to get it from the data only anyway. So if you modified the data, it will be helpful to understand the visualization very easily. So instead of going the Power BI, you can also try with Python. This is a basic strategy to follow every industry. Okay. So yeah, we are just taking the cases per 10 million as we just now discussed, so that we'll get some idea of what are the different stresses causing with the 10 million per cases. Yeah, you can see the data frame. Yeah, for the cases for 10 million, around this much of the count for the Gujarat and this much of count for the Maharashtra. And you will also get to know about some of the cases with corresponding to, yeah, with corresponding some sorting out the descending order or ascending order. Currently, we are doing within descending order. Yeah, you can see the most cases per 10 million is the Ladakh, when compared to the all the next with the Delhi and the Maharashtra came into the picture. Maharashtra at the time is the top, right, for the death and also the confirmed cases, but it went to the third position. So why is went to the third position? That is a question right now. So how to look on that? So what you need to do, how to look on that? So then go to Maharashtra. What are the different deaths and what are the different curated when compared to the previous date? You have to like that, and you can also take some, you can say take some consideration, some statistics, then you can compare both the things by using the two data frames. That is also one strategy to follow. And secondly, you can say only the one depth in Ladakh. Why it is happened only one depth? What is the reason to get the one depth? You can also see some of the cases are 12 depth, and some of the states had only 3 depths. 12, some cases had 0 also. So what is the strategy they followed? So taken some other data frame, I mean, they will confirm what are the different events that they conducted and what are the different, you can say, different kind of mechanisms they have to follow. Similar, you can say different governments and similar strategies. So if they will work out at that time, how does that going to help us to decrease the death, and how does that going to help us to increase the confirmed cases? So at that point, you will get some idea how they applied this kind of the strategy. So you can also implement this solution in the newspapers, right? That's how they are writing these newspapers. They, according to some of the data analysis, they're going to write some of the newspapers. And you will also get from something called as a movie reviews. Okay, movie reviews is not came from sky. Okay, it will came from some person. You have to write some code and you have to do some analysis, then only you will get some to understand whether it's a positive review or negative review, or whether it is a good movie or the bad review. You may not be get it from the Google. Google is just for to get the information, that's it. But actual review came from only while doing some analysis. So okay, so yes, similar kind of the stuff. You can also play around with this, just for the confirmed cases taking the greater than the 30,000. Why it is taking? So you can see the most of the cases are above the 3 countries. Above the countries are most of the cases. We can also do some average and take that consideration as a threshold. Then we can move forward. But yeah, just plot it according to whatever the number of cases and per number of per classes confirmed cases what we had. Yeah, this is just a scatter plot to understand how does different states having the distributions between the number of the cases per 10 million people and also the number of confirmed cases. And you can see the most number of the cases are most number of the states are fall into this place, that is less than of the 50,000 number of the confirmed cases. And yeah, Ladakh, you can see Ladakh is a very top, and it is also per number of the cases per you can say 10 million people is very high when compared to the Delhi, same as we just seen this, right? So same as like that, just for visualizing purpose, to get more clarity, you can also Delhi, same as we just seen this, right? So same as like that, just for visualizing purpose, to get more clarity, you can also write some you can say some interesting English words to understand this graph. to understand the scatter plot. So yeah, have we already seen this heap map yesterday? I hope you remember how does we going to be computed as a correlator matrix. So you can see this coloring map is going to be help us to understand if it is going to be darkness, that much of darkness in terms of black, we can call it as a non-correlated features, and whenever we have some whitish color or orange whitish color, we can call it as high correlated values. You can see this region is a very high correlated when compared with, you can accept this one diagonal, you can see this something called as a depth and versus curate and confirmed versus curate. So these two are very correlated with each other. That means it is slightly dependent on this one, curate persons and also the death persons, along with you can say confirmed cases. So whenever some patient is confirmed or whenever such patient is confirmed, we notice that they have death. They had already death. They already died, you can say. And whenever some person is cured, we're confirmed as a he is also dead. So like that, it's going to be confirming, or you can say this completely depending on other feature. So depends on the depends on the requirement they satisfied, but we had to understand why it is correlated with that much of probability value. We can also call it as a probability value, or you can say we will go into this value according to whatever the different features we had. And yeah, so other data set, individual data sets we had, you can see some government ID, diagnosis date, and what is the detect city, and state wise and nationality, current status. So these are other data frames, I can say. You can also play around and join with the two tables what we had. So here we're just taking the some districts wise instead of taking the states wise, so that it may be helpful to understand what are the different districts I have caused together with the confirmed and curated and the death cases. Yeah, so the males and females ratio is very you can say imbalance between the two the things with regarding confirmed and the those of you can say death cases. And you can see another data frame. This is I think this is also another, yeah, this is the same, this is the same. So yeah, in this case what we're just going with the diagnosis set what we had in this data set. So counting number of the diagnoses and some of the cumulative results according to the year wise and also the month wise and also the day wise. So that we get some clarity and with regarding whatever we just know, and we can also join with that our assumptions. Yeah, let's go with this, and we can also plot maybe some other. Yeah, you can see. I think this is related to number of days. Yeah, so the number of days with regarding the number of cases what we had with each city and also the districts. How does our India is growing with some of the cases at the time of 2020s. So you can see the number of days are slightly increasing at at the point of after 30 days, it's gradually increasing, or you can say it's rapidly increasing without any changing. It's almost a peak of probability distribution. You can say this is the first standard distribution, and this is the second third standard distribution. You can also call it as it will went up to another line. Maybe it will be peaks around the mean value, and then it always going to be gradually, right? If you go to the Google, you can see that mean value, and if you go and type maybe covid COVID-19, it will give that statistics. Yeah, here only, right? Yeah, you can see this line. So whenever you get the sum of the probability value or the sum of the Gaussian value, it starts from this area. Starts from this area. So it's likely going to decrease sometime. This is the mean value. This is the mean value. This is standard deviation 1 and standard deviation 2, standard deviation 3. So this may be called as a second wave or first wave or the third wave, right? So this is a wave we can call it as. So We're going to be get as a Gaussian distribution until it's going to be spread something. You can also see it's slightly increasing nowadays. Slightly increasing nowadays. It may be possible to get this peak. It may not be possible to get this peak. But we have to calculate somehow skewed. Okay, it's somehow skewed. You can see we have to transfer to some Gaussian distribution. We can also analyze by using the time series analysis. How does next wave will come up or not, and how does the next wave is come up after a couple of the days. We have to do that. We have to do some analysis by using time series. We have some mechanics to do that. Instead of taking this data frame, we can play around with this data frame. You can also extract this data frame maybe by using Google. You can also extract by maybe Excel format or the CSV. But this is a very huge data. This is world data sets we have going to be calculated. Okay, so yeah, like that you can play around with these data sets. I have already given this data sets instead of calling the some state by state and also the country by country. So these are all some logics to understand. You can also play around with some of the logics if you want to know. And if you don't want to know, just Google it out, some of the logics like how to calculate the median value and how to calculate some of the percentile values. You will also get the logics formulas. Then you will calculate by using the Python. We already learned the Python, right? Some of the skill sets. Yeah, these are simple, I can say. You can play around with this. Yeah, you will also get from the each and every step by using the line how much the day count is increasing with respect to the number of the cases. Yeah, this how you have to write at the end. You can say this how you have to write so that the someone will go and check out this and they will implement and they will also take some decision according to that. Yeah, okay, folks. We're going to be wrap up today. What you need to do, you have to practice this. Then we're going to be explain tomorrow and deploy any kind of the machine learning models. So what will happen if you deploy this model? This is not a last steps. This is just a you can say middle of the step. After this deployment of the model, you have to monitor the model. Okay, so you have to monitor the model. So unless until you cannot monitor the model, how does you know after completion of your model building, maybe 30 days, it's going to be works out or not? If it is does not works out, you have to come again. So that is a life cycle for this. You have to come again and recheck about the feature selection or maybe the explorated data analysis or the data pre-processing steps. And why this arrow came into the picture? Once you select some of the features, let's suppose you have built a model. This is some independent features you had taken as a trained data sets and you have built a model on top of it. You got some output, some precision or the recall you want to be evaluated by using that. So at the time you got around 0.87. And what will happen, the end user, the customer or the client may not be satisfied with your precision 8.7. So you have to go and recheck that, how to increase that precision and how to increase your model evaluation. At the time you have to be faced a lot of the issues like feature selection process and how to optimize your code and what are the different methods to use instead of using only our approaches. What are the other different methods we have in the market and what are the different tools or libraries we are going to be handled. So we have so many libraries, not only NumPy, Pandas or Matplotlib. We have so many libraries. I will also explain to you what are the different libraries we have. Predefined libraries or open source libraries, or you can say even private libraries also we can use by using some keys, okay, access keys. So it depends on that BRD. How does that going to be make us and what are the different models you have to be showcased, and you can also present with respect to the feature selection process, or you can also present by using the model selection process. So every model does differently. Even we cannot select a model whenever you see some of the data, so that that assumption may not be works out all time. You have to be handled with all the models. You have to select one of them. Similar to the feature selection process also, you have to do some all the methods, technologies and approaches, then you can pick up one of them, and whichever gave the good results you have to pick up them. So that's how the life cycle does. Every time you eventually go through some of the trial and error mechanisms. Whenever you got stuck, you can do the next one. So let's go and discuss with the tokenization mechanisms what we learn and what are the different cleaning and text pre-processing we are going to be handled in this notebook. Similarly, we can also go to the Amazon Find Food reviews in this notebook so that you will get some familiarity with this. Yeah, let's go with this text feature processing. Then we can go to that. So I have a text with corresponding to txt file. This is some txt file. We had some text here. You can also see this. So we already discussed how to open a file and by using with open, and we can also use some of the mode operations. I hope you remember this. We can currently we are just reading the text whatever we had inside the txt file. So this is some sentences corresponding to the text we had. So let's play around with this text corresponding to the text. You can say text pre-processing and also the data cleaning stuff. Yeah. So take this data set into the data frame wise. I'm just converting as a pandas data frame with corresponding to the title and also the publisher. So whoever the publishing with corresponding to the title, I'm just printing some of the publishers names. So just creating some data frame and I'm just outlining this. You can see. So yeah, so this is just extracting data from this resource. So if you go to this link, yeah, if you go to this link, yeah, I think I already opened this. Okay, yeah, you can see this link. We are just extracting the link from the quotes. You can see the http dot underscore the quotes in the quotes JSON file. So what will happen if you just extracted the JSON file? So it will give some of the relevant contents or the some of the codes. You can also see it contains some of the JSON format. If you go to, yeah, if you go to this link, what will happen? You will get some of the job sequences and you can say the other posts and other tab comments and ask, show, submit. These are the some of the tabs we had, right? So under these, we can select any one of them and we can extract the data. You can also do by using the Beautiful Soup, and you can also use by using the Selenium. But currently in this notebook, we are using the Beautiful Soup. Beautiful Soup also the very good library to extract. What will happen if you extract open source websites like Amazon or Flipkart or any websites with regarding some consist of data? It will block your APIs every time you want to export it, or if you want to be extract some of the data, it will block obviously your IP address. So this link is I think some news link. You can also go through this news link, hacker news, some of the news like this, which is not in our India, I guess, which is the some other, but it may not be block your IP address. So that is the reason I'm just picking up this, and you just try to understand, give the some request to the according to the link. You can go through this link and get some text from this link. So let's see how does we are going to be extract. So this is the regular expression, importing some regular expression to handle what are the different character to analyze, and extracting some of the HTML characters to delete. So if you go to these links, you will get raw data like this. Okay, this is some HTML request kind of the thing. If you aware of the some of the HTML, you will get understood like this. This is the head part, and this is some of the body parts we are going to be showcased with regarding some anchor tags and title bars. This some references links also you can see. So this is converted into the HTML. We have to be you have to be structured whenever whatever the possibilities we have. So completely this is a raw data whenever you fetching from any websites or any kind of the services you are using currently. So we have to remove some of the HTML tags what we had, and then we can structure into the whatever the formats we required. Currently we are focusing more on the structure, tabular structure format, right? So we can do that. So converting some of the HTML tags by using the regular expression. Compile is just doing some of the tags to remove. And similarly, we are going to be replace some of the blanks what we had. You can see there's so much blank we can also see here in this HTML. Yeah, let's go and see that how does the Beautiful Soup going to be help us. So as we just now discussed, removing some of the HTML tags and just converting with our whatever the text raw text we had. So this is the raw text we had with corresponding to the each and every tag. Yeah, yeah. So you can see the all the articles with corresponding to So I think we're just extracting the TR whenever the class consists of a thing like this class. So just for the article to know about that, this is some text we had to download with the text preprocessing. You can also try it with some other classes or maybe some other tags. That is also fine. Yeah, so extracting some of the title with corresponding to the text what we had, and you can also go and see the what exactly the titles we have, some different titles we have. Yeah, so yeah, this is just finding some of the article and extracting some of the title according to whatever you need. You can just type and what are the different classes we had. Similarly, the anchor tag we are just pulling out, and the tr tag in the HTML. So you can also print some of the text you want to be explorer. That is also fine. So you have somehow explored some of the text. This is up to, you can say, the extraction of the modeling or extraction of some of the text, some of the data. So every time you cannot be do this because they will going to be blocked some of the IP addresses. You have to access to the whatever the reference website you have, then only you can access to that. Otherwise, it may not be helpful. Yeah, then we can do some of the cleaning part. Maybe we can also call it as a normalization to do any kind of the text conversion, you can say, to avoid some of the cases like removing of the special characters or the emojis and converting to a lowercase. So yeah, this is some sample text we are going to be taken consideration from the above scrapping, maybe you can say, and converting to the lowercase. It will convert all the characters to the lowercase, whatever the characters we had. And similarly, you can see the punctuation removing more. You know, right? Some of the punctuations is going to be removed if it is going to be very noise data sets. Currently, it is not that much of noise data set. You can also see it is not that much of noise data set, but if it is a possible, you have to handle all these things. So we can see that maybe in the Amazon Find Your Reviews data sets, you were going to be understood to remove the lot of the things when compared to this sample text, and converting to the lowercase, then converting into the tokenization mechanisms, what we just now discussed, splitting into the sentences into the words, then we can convert into the vectors by using the bag of words. So the NLP context, we can also call it as natural language toolkit. This is going to be very helpful whenever you require to do some operations in the NLP context. So just declaring the NLPK, you can see NLTK is going to be help us to do a lot of the things, not only operations with regarding the data cleaning. We can also model by using these toolkits. Yeah, you can see we are just pulling the data and appending to the whatever the NLTK data we have. Yeah, this is the another sample text. You can see this is another sample text we are going to be consideration to do some word encoding and tokenization mechanisms to convert from sentence to words. So what it does, splitting the text into some of the sentences. You have the raw sentences. You can say with raw corpus you have, it's going to be splitted into the sentences, and then we can convert it into our words. This is how it's going to be works out every time. The NLTK corpus is going to be help us in terms of the stop words also. We have to remove some of the stop words. So I will show you what are the different stop words we have corresponding to in the English context. And yeah, so this is also one of other text we are going to be take consideration to do. So what it does, this regular expression, we have to be showcase only for the alphanumeric characters. All the remaining you can say all the remaining words or all the remaining alphabets is going to be removed when compared to lower characters, and also the capital, you can say lower and upper characters, and also the digits if you have any digits, and just convert into the lowercase. So these are some you can say data cleaning and the data pre-processing steps to understand. Okay, so this is not a regarding any kind of the project or any kind of the things. Similarly, the stop words and something called as a sentence parsing. So sentence parsing, what it does, we have to learn something called as sentiment analysis, right? I mean semantic analysis. How does word to wake model going to be learned? Whether you have a word with corresponding to the word. This is regarding to that whenever you have some sentence, it's going to be parsed with the other sentences. So that we can also use some of the cases, and stemming and lemmatization model going to be learned whether you have a word with corresponding to the word. This is regarding to that whenever you have some sentence, it's going to be parsed with the other sentences. So that we can also use some of the cases. And stemming and limitations. Stemming and limitation, what it does, whenever you have the two or three kind of a similar kind of the words, like you can say some word called tasty, the tasties, and suppose some other word like taste, you can say tastis is like this is not a word, but I'm just explaining some examples. So it's going to be give as a root word according to three words, so no need to create the three word characters or three word embeddings. It only give the one embeddings according to that. So that's what the lemmatization and the stemming going to be help us. Similarly, yeah, you can see the lemmatization and stemming, whatever the root words we had, it's going to be give the same thing. So let's go and discuss with Amazon Find Food Reviews. This is going to be very brief introduction about some of the text cleaning and the pre-processing steps. So the data set is going to be looks like from the Kaggle. You will also get this link in this notebook, the Kaggle Find Food Reviews. It's already there in the Kaggle. They already provide some of the notebooks and also the code. So these are some of the columns and some of the row sets with regarding the. You can also download from here the reviews.datasets and the SQLite and also the hash.txt. So we have SQL dataset, and you can also say CSV file with corresponding to the labels Amazon Find Food Reviews. And the number of the reviews we had around 5 lakhs rows, and also the users they have given the 2 lakhs, corresponding number of the products they are using. And we need to predict by using a review, we need to understand whether a customer is satisfied with the product or not. So what will happen with regarding the Amazon Find Food Reviews means, so you have a website with regarding the Amazon, you purchase something like any find food, suppose you can say you purchase something, your product item, along with you had some, you added some review, user will added some review. So it will what it exactly does, it will take that consideration whatever the model they build, Amazon people or Amazon team they build, it will collect that review and it will predict the rating. And you can also say whether it is a positive review or the negative review for this case study, for this case study. So how do you predict whether it is a product, whether a customer is satisfied with corresponding to the product or not? So we have something called as a rating system, right? Like when you give 5-star rating or 4-star rating or 3-star rating or 2-star rating, 1-star rating, what exactly it's going to be help us in terms of the positive and the negative reviews. So I will consider something called as 5 to 4, maybe the positive review. If I give someone the 5-star or the 4-star, it's obviously based on the BRD what exactly they made. Okay, it does not depends on us, it does not depends on the individual decisions. It's have to make some of the business requirement whatever they need. And I will also take 3 to 1 as a 3-star to 1-star rating as a negative. Some of the people may call it as 5 to 4 as a positive, as a 3 as a neutral, and 2 1 as a negative. So you can take that is also fine, but I'm just explaining as a binary class classification in this task. Binary class classification, that means I had to take only two, whether it is a positive or the negative. So I'm just assuming 5 to 10 is a positive and 3 to 1 is a negative. So like the way it's going to be works out in this notebook. So you can see we have some different attributes or different variables we had. Some customer ID, you can say the product name, unique identifier of the some of the product, and the user ID, profile name, helpful numerator and helpful denominator. So these are some of the terms, technical terms in terms of the Amazon. They are going to be they're going to be handled in this Kaggle project, in this Kaggle datasets. So if you go and understood what exactly the helpful numerator and the helpful denominator, number of the users who found the review is going to be helpful. I mean, they are dividing some of the calculations according to the users and also the review. it's going to be helpful or not. Similar that you can say the helpful denominator, it's going to be help us number of the users who indicated whether they found the review helpful or not. And they already made some conditions. According to that, we have a helpful denominator as a column according to this. So score we just given as some rating five, up to you can say the 5 star. Time they when they are going to be purchase some of the product item, some of the brief introduction report, some summary kind of the thing, along with the text also, what exactly the text we had, text of the review. So like that we made something called as 4 to 5 as a positive and the 1 to 3 as a negative. So you can see we have two data sets. One is a .csv file and also this SQL file. So we're going to be import SQL consists of large set. Okay, I will share with this link. You can also download this instead of sharing these files. So this is very large data sets. You can directly download from the Kaggle itself. So just importing some of the libraries, we already learned some of the libraries with recording to the scikit-learn and some of the extraction, TF, IDF, encounter, and also the bag of words and some of the matrices we already run, and also the so Porter stemmer is nothing but whenever you do some stemming or lemmatization techniques, it's going to be helpful by using the NLTK or the toolkit. We are going to be retrieved from the toolkit. Yeah, so these are some. Yeah, Gensim is also a very good library from we are going to be get as a word-to-vec models. I'm currently not going to the details of the word-to-vec, but word-to-vec makes some kind of knowledge on the deep learning stuff. So we're going to be see how does the word-to-vec model by using the Google News and also the Glow vectors. Maybe it's possible to go that just for understanding. Yeah, you can see that we just connection between our notebook to our SQLite. You will just connecting by using the SQLite what they are provided. And you can also see we are just filtering some of the rows, because what will happen, we have so many rows in this data sets. If suppose I'm limit myself to up to 10,000, so we have so many rows. So 5 lakhs rows we have. If I make the 5 lakhs rows and download or load it into my pandas, it will be hangout anyway. At the time you have to use the PySpark. You can say you can also use maybe the optimization functions to visualize the things, but this query going to be help us to understand to optimize some of the rows. The row count not going to be exceeded at the time. And what will happen, some of the scores is going to be greater than or the less than 0. So I just make it whether the positive score is going to be a 1 and the negative score is going to be 0. So like that we are going to be made with regarding zeros and ones. This is very easy to understand. For a binary class classification we are going to be handled. Instead of taking the positive or the negative, we are directly changing to the zeros or one at the beginning itself. Yeah, so changing some of the reviews with who are having the less than 3 and also the positive. Yeah, this is the final data frame we are going to be retrieved. Only we have 1 lakh records, you can say, along with 10 columns or features. So this is some of the features. You can also the helpful denominator and having with binary or ordinal values along with the time. Time is not make sense. We can ignore as of now. It consists of some format to do the things. And similar the summary and also the text we have. We just play around with this text as of now, along with some product ID maybe. Or you can also take the profile name consist of some names here, along with the summary. Yeah, so let's print it out. How does it going to help us in terms of, yeah, you can see the some sample user, whatever the users we have. We can also check some of the duplicates if you have. So you can just print out maybe the duplicates by using this. If you know the SQL, having it's going to be help us to understand, you know, whether you're going to be use any kind of the count functions. So I'm just printing. If you have a more than record, you can say the more than one record, it's going to be print the count. So these are some of the samples. You have more than 2 or 3 records. So this is somewhat a duplication, you can say. We have more than one record when considering the with using the same user ID, whatever they purchase the product, different products. So according to that, you can search, and you can also some of the cases what will happen, you have to drop some of the features or drop some of the rows if it is a very duplicate rows when compared to the same product. And yeah, so let's go into the discuss with the exploratory data analysis. Yeah, so data cleaning and do duplication is going to be done here. You can see we're just printing out with corresponding to some user ID and also the score, which does not matches with the three, and ordered by the product ID. I hope you know some of the SQL queries, right? Select start from the table name, and we are using some weight class, just ordering by the some product ID. So I am assuming you know some of the SQL to understand. So this is some sample to query to visualize the things when compared to in any kind of the you can say any kind of the environment. You can use maybe PySpark code, or you can use maybe the Python. You can also use the Scala for that matter. In any kind of the SQL query, you have to write it out. Yeah, so these are some of the duplicates with corresponding to whatever the this user ID, whatever the user ID we had. All the users consist of, but different you can say the different product IDs maybe. The product IDs might not be the unique, but the user ID may be the unique. These are some of the products they purchased with corresponding some text they also given according to that. Yeah, so what will happen if I remove some of the duplicates like that, and it will do some of the data leakage for me, right? At the time you had some unique product ID, you don't want to sit idle to do some of the dropping of the duplicates. So it does not make sense at all. So how much percentage the data is going to be remains if I do the duplicates? So let's check that. I'm assuming some of the product is going to be unique. So that's why I'm just sorting out what are the different product sizes we had. And we can also filter, and we can also do duplicates. What are the different product ID according to that? So I'm just dropping some of the users we had as a duplicate values. If suppose you have a value around, you have a value for first user, let's take, you have a data set according to the user ID. So you have a value with corresponding to the same user ID, or you can also say some same using a date of birth. You can also consider some of the cases, and two again two. So we had to remove any one of them. We have to remove any one of, whether it is a product item is very different or not. That does not matter, because this is must be a unique column, or you can say the primary column. We can also call it as an SQL primary key. We can call it as. So for this matter, we had to remove the whether consist of the username or the profile name, or the same time means that may not be make sense at all. And the text, some of the cases may be matched out with corresponding the user ID. So if any records going to be such like that, we have to remove. Drop duplicates does the same thing. We have to remove some of the cases. You can see 1 lakh rows is patched up into the 87 rows. So that's how we have some of the duplicates in our data sets. So it will happen some of the cases because we are using the raw text files and metadata. What we do in the source side, what exactly they're going to be do, whether they are using some Oracle, you can say, or some SQL kind of the databases. So by using these databases, they will fetch from some pipelines. They will fetch from pipelines, you can say. So what will happen inside this pipeline? They will do some transactional data. We can also call it as fact tables for that matter. And this is we can raw data, we can call it as a dimensional tables or the dim tables. So whenever they do some fact tables is the transactional tables. Okay, transactional tables, and dim tables are just raw tables or metadata. So whenever they do some transactional data with corresponding to the dim tables, it may be find duplicates. So these steps, its tables are just raw tables or metadata. So whenever they do some transactional data with corresponding to the dim tables, it may be find duplicates. So these steps, it's going to be done every time, not only this project, any project you can take. So raw data may not be satisfied with your decision you have to make in the data scientist path. A data scientist rules and responsibilities you have to done in the IPython notebooks. So you have to be get get rid for all these things. You have to be look for the duplicates. You have to clean up the data by using the missing values or the outlier detections. Everything it comes under to you. You have to handle it with the structured data whenever the possible. And you can see some checking some how much percentage left out with corresponding to the data sets. So we just now taken 1 lakh records. So this are the percentage data we had. You can say around 13% data we had leakage with corresponding to that, but typically may not be acceptable whenever you do this in the real world. They need at least for 95 to 97% of the data whenever you want to dropping some of the rows. You have to try out with the different techniques, whether you have to handle with maybe unique values going to be present when compared to the user id, or you can also go with some time frame based mechanisms with whether slipping with only the raw features we had. You can also take that features and consider into the machine learning model. So different approaches we have to follow, not only the one good approach, not only the one bad approach. Yeah, let's take maybe the another user id and let's perform the deduplications if there is present or not. And according to that, we cannot find that with corresponding to that, and user id whatever we had, it's completely different to us. And yeah, so let's go and do some pre-processing whatever we just now discussed with regarding the other notebook. So first what will happen, these are some standard steps. Okay, this is not mandatory steps, these are some standard steps you have to follow. You have a data with text. So begin with some of the HTML tags to remove the punctuation marks, whatever we had, some special characters, maybe like asset symbols or the red symbols, and some checking whether it is in the English format or the other languages we had, along with some alphanumeric. Okay, and you can also see we had to check some of the length. What will happen, the sentences you're going to be seeing in the raw data sets, you can also extract from the Twitter. Okay, if you extract it from the Twitter, maybe the comments or maybe the post or the titles, you will get different alignment of the data. You will see the very alien kind of the stuff whenever you extract from the Twitter. So in that case, you are going to be get the length is very high, some of the cases. So for that reason, as in this notebook, we are just considering as a greater than 2. Whenever you had some word length is going to be greater than 2. And also we are just adjusting to the 2 letters characters and converting from lowercase and removing some of the stop words. So I will show you how does the stop words going to be looked at and what are the different stop words we have. Yeah, stemming, we're just applying some snowball stemming, quota stemmer we have. Then we can apply to according to our text. Yeah, so this is I can say we are just storing into the some variables like send is equal to 0, so that it will going to be understood what are the different values we are going to be present with corresponding to the text. So we are just taking and from whatever the values we had, like whatever the raw text we have according to the 87 rows, right? According to the 87 rows, we are going to be fetch and we are going to be do some of the operations what we just now discussed. Yeah, let's do that. So removing some of the HTML characters and special characters. So regular expressions is going to be helpful in this situation, because in the regular expression we go and see the documentation, removing some of the URLs or the HTML tags. Yeah, so this documentation is going to be helpful. If you go to the documentation of the regular expression or maybe the Stack Overflow kind of the thing, this is going to be very helpful. You will also get tons of the codes here. Okay, so someone will use and someone may not be used, someone may not be satisfied with answers. So you will get a lot of the code whenever you want to search. Regular expressions having tons of the functions. No one going to be remember the tons of the functions. To go and search the regular expression docs. I hope you'll learn maybe the if you are computer science graduate, compiler design, you will get the regular expression sums, whether you are using the DFA or the NFA. Here you can see tons of the documentations you're going to be learn so many things. This is very large documentation when compared to the other. So what you need to do, just learn up to the standard stuff whatever we are just following with the NLP context. If you need any time, you can go and see the documentations. That is the handy and that is a preferable solution. Yeah, so similarly we are just doing to remove all the tags, whatever the HTML tags we had, along with some of the URLs what we had. If it is a URL, it's going to be removed in the text or the sentences. Yeah, these are simple operations to perform, you can say. Yeah, see, yeah, these are the some, you can say, TQDM to perform. That means we are going to be give some progress report to the all the text format. We are storing in a one file and we are just extracting and doing some of the operations. And what will happen if you have a text like this? Won't. So won't or will not. So it may not be make some sense to at all, right? Some specificness you're going to see. You can also see something called as this one, not and aren't. And this may not be make sense at all. Some of the cases you have to write some s. You can say exclamatory mark with the s. It may not be works. It and ll we can also write it at t, have, and am. Some of the cases we're going to be write like this. So in this case, we had to pass some of the other words like this: will not, and cannot, like in not, and and or not. So it's going to be remove at the end, I can say. But until unless you cannot be identified this is what exactly the word is, it cannot be removed by using the stop words. So that is the reason we are handled with this word. Obviously it's going to be removed by using the stop words. So let's go and check out what exactly the stop word does. So these are all the stop words you can see here. It may not be make sense at all when you are doing some modeling or tokenization mechanisms. It may not be make sense at all. That's the reason we are just removing these stop words. You can also go to this documentation maybe so that you will get some idea how does that going to be helpful, the stop words. Yeah, you can see this, these are number of the stop words we had. No, not only the so many stop words you are going to be seeing these documentations. These are all the stop words we are going to be handled. So some of the cases, what will happen if you remove some of the stop words like bean, like you can see the bean or the bee, maybe the case that will also have some verb according to the context or according to the sentence. Like if suppose you are creating some chatbot, let's take that example maybe. So you're creating some chatbot. Chatbot needs more data to understand. Chatbot need more data to understand, to give any, you can say, to give any kind of the response from the user. So to give any response it needs some identity to identify. At least it needs some identity to identify. If suppose you are typing something, i want I want a coffee. So like that you're just searching like this in a chatbot. Obviously it's going to be give something right according to this coffee. Whether they will ask something called as which coffee you want, or which coffee you want to preferable, and what is the price according to this. That much of information you require to buy a coffee or to book a coffee. If does not make sense at all to give any kind of that information, obviously the customer may not be satisfied with the requirement. So at the time some of the cases, stopwords may not be removal, and stopwords will be removed only few of the cases. It depends on the data, it depends on the context you are working on. So currently we are working on the text class classification, so that is the reason it may not be helpful according to our text class classification task. So that is the reason we are just removing this number of the sum of stop words. So what will happen if you remove this number of the stop words, and what will happen if you remove this number of the start words? So many stop words you can see in this documentation, but you cannot be remove all the words. You can remove only the few of the words. So that is a basic scenario to follow, and this is not a mandatory. This is you can we can go with the standard mechanisms to follow every time. Yeah, you can see we are just doing whatever we have done till now, like removing of the HTML characters and going with some any kind of the XML kind of the thing, or you can say removing some of the punctuation marks and also the converting to the lowercase. And we are doing some only up to the mark of alphabets going to be present in our text without anything else. So that's what we are doing, and we are just iterating with this TQDM library. TQDM it does that going to be do, it's going to be print this progressive bar. Okay, so how many reviews we are going to be cleaning with corresponding to the different values we have. So after cleaning also we are going to be get the same results, because we just remove the within a text, right? We not remove any kind of the text according to our deduplication. From some of the pre-processing review what we have done with using futurization mechanisms. You can see here the bag of words we're just applying to the whatever the clean text we had. So the clean text is going to help us to identify what are the different tokenization mechanisms to encounter with different values. So these are some of the features values we have. So we already seen this code, right? Count vectors to import from the scikit-learn and just fitting our whatever the reviews we had, and then we're just printing some sample review. You can see the sample review consists of different values, and according to these different values, it's going to be convert what exactly the count vectorizer is going to be help us. So this is a count vectorizer shape. You can see we're just converting the count vector to get some space. You can say fit and transform according to the pre-processing text. So you can see the dimensionality is slightly increasing when compared to whatever we have done when compared to, you can say, yesterday's notebook. Obviously it is going to be create a lot of the space. It may not be identify the semantic meaning, or it may not be identify the similar kind of the words, but we have tried with the lemmatization technique that may also be helpful, and something called as unigrams, bigrams, and also the n-grams. This is one hack in the future engineering. Whenever you do any kind of the tokenization mechanisms, if suppose I created this much of dimensionality, I need to decrease. Okay, I need to decrease this much of dimensionality. At the time, what will happen? You can go with some hacks. If suppose you just having this much of count, but let's take I have some of 10 lakhs, or you can say 10 million kind of the dimensionality. So at that time, I need to handle that stuff. How to handle by using that stuff? We need to analyze some of the hacks like this. Backup, or you can say this bigrams or the n-grams. You can say the unigrams. Bigram, what it does, it takes the two words instead of taking only the one word. Currently, we are just taking only one word, right? So instead of it taking the two words and collecting together and applying the backup words again. Similarly, you can say the n-grams. You can specify according to your requirement. If you want to specify, you can take consideration for the 2 gram or the bigram is going to be works out. And if you don't want the 2 gram, you can also specify the n-gram. You want the 4 gram or the 5 gram. That means you can take consideration for 5 words or the 4 words or the 2 words at a time. At a time. So take consideration for the 1 to 2. You can see the n-gram range. We can directly specify the n-gram range in the count vectors as a parameter here. These are some of the parameters you can also pass. If you want, you can go to the documentation, you will get it there. And in the n-gram, you can type, currently I'm doing the bigram up to, you can see unique 1 for unigram, 2 for bigram. You can also specify, instead of 2, you can specify the 3. That is also fine to get the trigram. Yeah, minimum, you can say this is just for the minimum samples we are going to be take consideration. And you can also apply the TF-IDF according to our pre-processing reviews what we had. Then you will going to be eventually get the dimensionality. It's slightly decreasing. You can see the 3000 only when directly doing with our raw data text what we had. You can also see this is also slightly decreasing when compared to the initial we had around 12,000 records, right? So 12,000 dimensionality we had. Yeah. So let's also apply the Word2Vec. What will happen if I apply the Word2Vec model? It will go and identify some semantic meaning according to our knowledge. So if we go and see how to apply the Word2Vec model, we have some drive link to get the whatever the Google News data sets we had. So take this data set and apply to our pre-processing data sets. So just download this. This is having a very huge files. I can say they're trained by using I already told you that 300 billion of the Wikipedia pages. You just downloaded this data set, which is in the format of, I can say, a pickle file maybe. Yeah, which is in the format of pickle file, .bin. Yeah, it's a .bin file. So Google News negative 300. Yeah, .bin file. So you can download that .bin file and just extract it here itself. You can also extract in your local PC and upload it to the Google Drive. That is also works out. But you have to enable the GPU for this cell. Unless you cannot be enabled, it takes a lot of the time to run. You can go to the settings, accelerator, and go to the enable the GPU. And what will happen if you train this model according to the Word2Vec? So it will learn so many features when compared to what we have just now seen with respect to the TF-IDF and also the backup words. I'm not going to the details of the Word2Vec model as of now. You can see you will go into some kind of the you can say count. some kind of the numbering format with corresponding to the each and every word. So it will identify some of the semantic meaning with corresponding to the distance they're going to be calculated at the end. But if it is going to be very far away, it may not be satisfied. If it is going to be very near to that, it will be cumulated together and it will identify the semantic meaning according to that. Yeah, so you can also apply what we discussed, average word to vec and TF-IDF of weighted word to vec. This is also some extension to that. So each and everything is very simple. Okay, so whenever you have done some backup words, you can take some average according to this, then you can apply to the word to vec model. So these are some optional, you can say, when compared to that. If you directly do the TF-IDF, that is also fine, and directly you can use the TF-IDF weighted vector vector, that is also fine. But anyway, you have to showcase some of the customization code. Okay, this code is already available somewhere else. If you go and type it, maybe TF-IDF weighted word to vec, that's going to be found out anywhere in the Google. But does not, you can learn from the concepts and you can apply some of the things. I also mentioned some of the comments here. You can also see this is going to be helpful to understand the each and every code. So just apply for the logistic regression so that we'll get some idea what are the different steps we have to follow. You can see the bag of words consists of this much of information to retrieve. Yeah, so let's plot it this using our hyperparameter tuning what we had. So we already learned C parameters, initialization of C parameters when we doing the logistic regression after applying the regularization, right? So if you take consideration only for the backup words to apply our logistic regression model, how does that going to be works out to get the good results? So you can see the C value I'm just taking from 10 to the power of minus 4 to, sorry, here I'm just considering as a 10 to the power of minus 3 to 10 to the power of 10 to the power of 4. You can also take from 10 to the power of minus 4, or you can also take from 10 to the power of 4. You can also consider some of the cases 1 to 3 1 to 3 result like that. That is also helpful. Obviously C is equal to 1 by lambda. And what will happen if I train by using the AUC? So why we are taking AUC? That is also first question. The AUC is going to be helpful whenever you have some text class classification techniques, and AUC will help us whenever you have some semantic or sentiment analysis. So this is, we can also call it as sentiment analysis to understand whether a review is a positive or not. And why we are considering only the AUC? Why not the accuracy results? And what will happen if I take consideration the accuracy results with corresponding to the positives? Let's suppose I got around 97% for the positive and the negative I got around 3%. It does not make sense at all, because if you have a review, we are just using some conditions to make that assumption, right? Less than 3, we are going to be make it as a positive. Less than around 3, or the less than or the greater than 3 is going to make as a negative. So if you get the accuracy, it may not be satisfied get the results, because we're not doing any kind of the probability to get whether it is a positive or the negative. But in the initial step of the AUC ROS result, we are just calculating some probability with corresponding some threshold. If it is going to be less than of that, around 0.5, we take consideration. If it is less than of that, we cannot be take consideration according to the probability value. So the probability going to be shown, you want to be take that review has a positive side or the negative side. So that's how the mechanisms to follow AUC ROC results. And you can also plot maybe the accuracy result, but it may not be satisfied with your decisions to make anything in the model. Yeah, so let's perform results. And you can also plot maybe the accuracy result, but it may not be satisfied with your decisions to make anything in the model. Yeah, so let's perform whatever training data sets we had according to our test data sets. We already split, I think. Yeah, we already split the data sets into the train and test with corresponding whatever the values we had. And you can see we just split it into the 70 and 30% with corresponding to the test. So yeah, let's go and wrap up to this, then we can maybe continue from tomorrow. So just applying the logistic regression, whatever the hyperparameter tuning we had. So I'm currently using, I think, grid search only to get the more familiarity, the values with corresponding to whatever the C value what we had. We're going to be get anyway, whether it may be ends up with the logistic regression. And currently you can say we are using the L1 penalty, but it may not be make sense because it's going to be create some large number of the sparsity value, that is misclassification rates is going to be very high for the L1. If you apply for the L2 regularization, that will be somewhat good results when compared to the AUC results also. You can say we're just fitting with our train and test data sets and just predicting some of the probability results according to our cross validation. So I hope you understood about the cross validation also. So cross validation is nothing but, so when you have a train data sets and the test data sets, we are split it into the 70 and 30 percentage of the models. So what is the meaning of the cross validations? Why we are taking the cross validations? So what will happen if you just apply the train data set for, you can say some computing the C, or you can say lambda, the hyperparameter tuning on the train data sets, or you can also perform maybe to trial out or the predict or the classification task, on the train data sets. Whether you are using the some of the independent variables to classify, to predict some values, or to get the some classification task, you can also maybe use some of the cases C or the lambda in the train data sets. At the time you use this one, and at the time you can use this into the test data sets. What will happen if you use the cross validation data sets? This is unseen data point, you haven't learned from your training results, or you haven't learned whenever you had training some of the model, you only learn from the train and test data sets. You can compare by using the train and test data sets, and you can apply that whatever the results you're going to get on the cross validation results. So you got around AUC results 0.87 for the training data sets. Test sets also you will get around roughly 0.85. So while doing the cross validation, you haven't learned, you just pulling up some other data, or you can say pulling up the unseen data what we had, you got around 0.7, 0.76, like that. So that does not make sense at all, because you had some other numbers in your train and test data sets. That means you are trained with some other mechanisms or other parameters to follow in the two data sets, but you are just applying to the cross validation, you got only the 0.6. It's slightly at the time it's slightly going to be overfitting of the model. That means you are not fitting right fitting with corresponding to the two or three data sets what we had. So that is the reason we are just taking consideration for the cross validation also. You can say we just split it into the train and the test and also the cross validation. So we're just applying to the whatever we had either regarding the train data set, we're just testing over to the cross validation data sets. Yeah, so this is going to be helpful to ROC curve according to the train data sets and also the test data sets. Let's go and find out how does train data sets and also the cross validation data sets going to be helpful with corresponding to the hyperparameter and also the AUC ROC results. So you can see AUC ROC results we take consideration in the y-axis and also the x-axis as a C. So if suppose the AUC ROC result is going to be improving our model, but C is going to be some slightly you can say slightly increasing somehow with regarding the cross validation. With regarding the train, it may not be helpful, but it will be helpful at the end. You can say it will be helpful at the end. But what will happen suddenly, it's going to be increasing, the lambda is increasing and also the AUC also increasing with corresponding to the train, and corresponding to the test or corresponding to the cross validation, you can see it's slightly decreasing when compared to the AUC results whenever C is increasing. That means we can consider maybe whatever the AUC, highest AUC we had with corresponding to the CV and also the train. The train we had around, you can say, optimal lambda. So optimal, what exactly the optimal lambda we had? So C is equal to 1 by lambda, right? So corresponding to that, if C is increasing, lambda is decreasing, right? So C is equal to 1 by lambda. What will happen? C will decrease, lambda will decrease. Sorry, C will increase, lambda will decrease, right? So C will decrease, lambda will going to be increased at the time. So you have to be take consideration what is the maximization of the C. What is the maximization of the C? You will get minimum lambda at the time, minimum lambda. So this is the criteria we have to match for the train and cross validation. By using this plot, you can say What is the maximum C? So this is the maximum C we had, and what is the AUC according to that? And what is the cross validation C? Cross validation C around 5, you can say around 5 C's value, and also the AUC is very less when compared to that. So according to, we are just training our training data sets, whatever we had. So we can take consideration over the training examples. What is the maximization of the C? So the maximization of the C is around 5, I can say around 5, not that much of integrated, or you can say maybe the 4, maybe the 4. You can see the constant line, it comes up from 0, so maybe the 4, but we can take consideration according to that. So the maximum C we are going to be take maybe in this range 0 to 4, and we are going to be get at the range of AUC results 0.98 to the 1 maybe. So we're going to be discuss maybe how to perform some different techniques, whether by using, you can say, whether by using the bag of words and TF-IDF, and also the word-to-vec model. We can directly apply to the logistic regression firstly with 1 lakh rows. We have to do, after completion of the model building, take top 10 features and apply all these mechanisms again. Let's see and take the difference between the two assumptions what we made, and also what exactly we have done previous steps, like average word-to-vec and also the TF-IDF word-to-vec, right? So we can also apply these two into the logistic regression. Then we can also find the ways to get the good solution or not. We can also apply to our taking some of the top 10 features or the top 20 features. This is also make some good idea to do. So we're going to do in the maybe the next class